Hello. Hello.
Everyone's okay? I'm just going to go get the people from next door. Alrighty. We should have some jumping music to wake everybody up. How's everyone doing this morning? Sort of, yeah. That's not very good. How's everyone doing this morning? Excellent. All right, that's better. Thank you. All right, everyone's a bit awake. I'm pleased to hear that. Thanks a lot for coming out this morning. My name's Simon Waite. I work for Microsoft. I'm based out of the Reactor here, most of the time focused on developer advocacy for our cloud platform, Azure. I'm not organising this event. You probably will have seen Sam and Stefan floating around, handing out name badges and welcome you this morning. They're the engine behind today. The Global Azure Bootcamp is a global event, as its name might hint at, which is organised by our community. So that might be Microsoft MVPs or others who work with the Azure platform. So I think this year, I think they're up to 325 locations around the world. And we're one of the bigger ones. So we ended up with a wait list of about 120 people and a total registration of about 230. So Sydney being Sydney, we'll probably get half of that, but that's okay. You guys are amongst the lucky ones. So what we're trying to do this year is that Everyday Hero link you see at the top of the screen there, which was on our holding screen as well. Unfortunately, one of the Global Azure Bootcamp organisers lost someone very close to him in the last month or so, and the organisation he works for over in Perth is actually participating in a fund run to raise money for the organisation that was helping him and his family through some hard times. So if you do find it within yourself and you've got a few spare dollars you'd like to donate, please take a photo of that URL and go and donate. It is a tax-deductible donation if you go ahead and do it. I won't go into too many details because I respect the privacy of the organiser, but if you want more details, come and see me afterwards. So that's why we have the link up on top. Today is brought to you by Vigilant IT, who are sponsoring the coffee, which is over in the fun zone just on the other side of the corridor. Cloud Solutions, which is part of Telstra, who are sponsoring the prize giveaway at the end of today, along with the Microsoft Reactor, which is this space. So the Microsoft Reactor is one of 7 locations around the world that's part of our Startup Scale-Up program. We do community-style events like this in this space, not always Microsoft-centric, but it's a great space where we can do these sorts of events and offer people like yourselves the opportunity to come along and get access to some free training and content. So that's it for today. Any questions before we get started? Key one. No one put their hand up and asked where the restrooms were. So the restrooms are back towards the glass door that you came in and to the left. And we do have male and female, so everyone will be happy. Lunch will be served later, so let me just maybe quickly pull up today's schedule so we can quickly run through it, and then we'll get Michael up here to talk about blockchain, and Aaron will be in the Reactor Theatre to talk about architectural baseline principles. Just give me 2 seconds. Run through for today, slightly ahead of schedule, which is good. Let me just get rid of that so we can actually see it. So you're currently sitting in the Hollows Theatre. As I said, this is going to be mostly developer content for today. The Reactor Theatre, which is just at the end of the corridor here, is going to be IT Pro focused. Every session is going to be about 45 minutes of content, and then sort of a 10 to 15 minute window for you to ask questions and change room if you want to, or take a rest break. The only exception to that will be the session before morning tea, where it's a 45-minute slot. You're more than welcome to grab the speaker after they're finished talking, and if you've got any questions for them, grab them then, but you will be eating into the 15-minute or 10-minute tea break there. Gee, I was hopeful that we'd get through a lot of coffee in 10 minutes. But yeah, we've got a great day lined up. We'll have lunch at 12:15. Just a quick show of hands here. We've got vegetarian planned. How many people here are vegetarian or prefer vegetarian? Okay, well, we should have enough to cover you folks easily. Good. We will wrap up about 5:15 this afternoon. If you do need to leave, as I said, that's fine, but you won't be in the prize draw at the end of the day if you're not here. You need to physically be here to win. Okay, without further ado, let's do a tech changeover. Michael, come up. If you're doing the IT Pro session with Aaron in the Reactor Theatre, you can hop up and go and sit in Aaron's presentation. And thanks a lot, guys. We'll see you later.
Thanks, Simon. All right, settled in? Cool. Just a quick raise of hands here. Who here already knows Azure or have already been using Azure? Okay. How about who here already knows blockchain? All right, cool. So not pretty much, okay. Fresh audience. All right, so you know that feeling when you've kind of like been presenting this topic for the past year all over the world, and you kind of like get different questions from different audience. So yeah, and I think it's, you know, a very exciting space because it's something that just keeps on evolving, you know. It's a very interesting topic and a very deep dive topic, to be honest. But nonetheless, it's really interesting, especially for me. All right, a little about me. I'm a dad. I work for a company called Redify, which is also owned by Telstra. I'm a Microsoft MVP for developer technologies. I've been in this space of blockchain, but basically distributed systems for around 2014. The history was around looking for, Byzantine fault tolerance. Then from there, you'll kind of evolve into understanding, okay, blockchain is a Byzantine fault tolerant architecture. Been doing a lot of running and reading lately, so it's just something I've been enjoying. Quick agenda for today. I'll be doing a very basic blockchain 101, targeting, what does it mean for cloud and stuff like that. And overview of blockchain on Azure, and what's the services provided by Microsoft in this space, as well as integration points. So just a very quick one. When I've been asked this question many times, why blockchain? Why can't we just use database, right? That's always the question. Well, to be perfectly honest, it's a very niche, type of scenario where you would actually need blockchain, okay? Blockchain is not the answer for everything, and it's not the one that can solve all the problems in your systems. But the very niche reason of why you would use blockchain is that if you have two or more parties collaborating to each other, and the cost of reconciliation to compare their data is actually quite high, that it makes sense to pay a third party. Then, instead of paying the third party, why can't they just have the same data? That's pretty much it, okay? So that's the very niche use case of blockchain. Like, different members trying to collaborate on the same data without having a third party to basically say what's correct. Okay? That's it. All right? The common mistakes that a lot of companies did when they were exploring blockchain is that they literally just replaced database with blockchain, like the ledger, and connect it through their API, and they assume that everything works. And they were shocked that actually it doesn't make sense because there are no other parties involved. Right. So the main reason why you would also, on a technical point of view, to use blockchain is to, avoid tamper-proofing. I mean, to have a tamper-proof data. And in order to do that, you need to have these four, attributes in order to say that the record is valid, okay? It needs to have certain point of reputation. It should be legal, or someone needs to be liable for that record. And there should be some sort of complexity around it. So in this case, in a form of mining or, validation. And at the same time, fees or stake in order to control and make sure no one spam the network. Hence, there are two major algorithms being used here. It's either you're going to use the proof of work, which is you probably might have heard from Bitcoin or the public Ethereum, wherein it's something you use in order to validate a transaction because there's stake involved in this. Right? So that person A won't just keep on spamming the network because there's a fee involved. On the other hand, in a more enterprise scenario, which I'll discuss today, is the concept of proof of authority, wherein you don't actually need to have a lot of those miners or those validators. You just need to have authorized members who are part of the party. Right. And it's all because we want to avoid the Sybil attack, which is basically tamper-proofing. All right, let's get to it. Quick demo of what's blockchain on Azure. All right. So I'm in the, sorry. I need to duplicate. All right, I'm in the Azure portal. All right, I have three resource groups here. The first one is the I'll just call it Parramatta Cars because I live in the West. And there's Bondi Motors, all right? So the whole concept here is that we want to have a decentralized shop wherein different members, regardless of which tenant, they can actually, collaborate. And in essence, Parramatta Cars doesn't own the record. And at the same time, Bondi Cars doesn't also own the record. They kind of like share the same record. All right. So to get started, go to just create a resource and go to the blockchain tab. There are a lot of templates available provided by both Microsoft and other vendors in this space. It all started back then when what Microsoft did is just created a marketplace where you can actually host virtual machine images. Okay, so people back then can just use images and use the VMs as their miners or as their mechanism to run their blockchain node. But eventually they evolved into coming up with a template. Okay, and this in particular, the Ethereum Proof of Authority Consortium is a template that's not just a virtual machine. It's the whole thing. Okay, it's a network. Okay, and in order to classify a network, let's try to show you how to create the whole Ethereum network. So first, you're going to put in your email address, which is basically the one just being sent once the process of provisioning the network is finished. You'll be notified, okay? Because setting up the Ethereum network actually takes some time. It takes around 30 to 45 minutes. So VM user is, because at the end of the day, it's still a virtual machine that you can actually SSH into or RDP into if you're using Windows. All right. Let's just say Parramatta. Okay. And password, or you can use an SSH key. All right. Choose a resource group. All right. Let's just. Okay. Choose a location. By the way, that's just the location of the resource group, not the virtual machines itself. Because on the next page, the template also provides you the availability to choose different regions. So as part of the template, you can already have redundancy and duplication as part of it. So you can choose different regions, say up to 5 regions. So you want to have your blockchain network not just say in Australia, you also want it to be available in Southeast Asia or other regions. So let's just say I'm gonna choose Australia East. All right, and this is where you need to set up how many nodes you want to be the validator. Okay, this actually determines the number of your power in the network. Okay, what that means is that as a member, say Parramatta Cars, if you have 2 validator nodes, you have 2 stakes to the blockchain network. Then, say for Bondi Motors should also have 2 validator nodes in order to have an equal stake of the network. Or else there's no point of, say, Parramatta Cars has 5 validator nodes and Bondi Motors have only 2. That basically already makes Parramatta Cars, powerful because it has 5 nodes and Bondi only has 2. Right. And here goes Ethereum setting. So here you need to set up your member ID. So in an Ethereum network, as of now, as we speak, we only support 256 members. So you need to choose a member ID from 0 to 255. Okay? Then the network ID is determined on what sort of it's like a port, okay? But it's basically a parameter in Ethereum to say which Ethereum network do you want to connect to. And the admin Ethereum address. So one thing to note about Ethereum is that Ethereum actually uses the concept of decentralized identity. So using the concept of, say, in this case, you can use the extension MetaMask. So MetaMask allows you to create a decentralized identity using a wallet. It's a wallet that's being determined by your address, and it comes with a private key to sign a transaction. Okay? So basically, this address is an Ethereum address that actually corresponds to an identity. It could be a user, it could be a transaction, or it could be a smart contract. Oh, and you can also enable advanced options. Say you want to have a set up a VPN. Okay, so say for Parramatta cars and Bondi Motors, you want to set up an exclusive network so that it's not openly, accessible in the public internet. You can also do that. All right, and monitoring, and this is just around monitoring your virtual machines. So you can use something like Azure Monitor in order to make sure that your virtual machines are up and running. Because another factor to consider is that if your VM dies down or your validator nodes dies down, then that kind of loses you some stake on the network. So that's why you need to make sure that your virtual machine is always up and running. All right, so after creating that one, you'll actually see all of these records. Just like what I mentioned earlier, it's not just a virtual machine, it's a whole network. So it comes with virtual machines, it comes with public IP address, it kind of have all those subnets readily available for you. Right. So this is the user interface for the, let's say, the admin portal of the network. Okay? So in this case, I'm logged in as Parramatta Cars, okay, with an Ethereum address of this one. So remember when I set up the template from the beginning, I actually used this address in order to set me as the admin. All right? So if I go to the admin tabs, that's me. So this admin, which is me, I have 100% support. And that means I have the 100% rights to add a new member or remove an existing member. Okay? Then, as part of being an admin, I get to have the validator nodes. So these validator nodes are actually these virtual machines over here. This REG101, REG10, and REG11. That's actually, those are actually those two virtual machines, okay? So in this case, I'm using those two VMs as a validator. Since I'm an admin, I'm entitled to have two validators. So on the other hand, Bondi Motors, I added them as an admin. So, I just nominate, add the address, and put it in there. Bondi Motors, on the other hand, also gets to have, okay. All right. Also gets to have an equal right. Okay, so that means Bondi Motors have also those independent, those two virtual machines that Bondi Motors own to be connected to the network to validate a transaction. Okay, so in essence, blockchain is just solving governance. Okay, it just solves that, it's not just Parramatta who's owning the record, it's a shared record. Because a validator node also has the same record across those different nodes. So all those 4 nodes, which is 2 of each, they have the same copy of the ledger. Okay, so that's kind of it. Right. So the thing is, in order to actually see what's happening within the blockchain network, you need the concept of an explorer, okay? An explorer is basically the one that determines what's happening across the blocks, okay? Because the whole concept of blockchain is that it's a series of blocks containing information or records that are tied in together. They are linked. They are a chain, okay? Basically, blockchain. So each and every one of those nodes need to have the same records, need to have the same copy of the chain, okay? So in order to do that, you need to have the concept of block explorer to actually see it. So in order to do that, it's just as easy as creating a virtual machine, okay? And from that virtual machine, say an Ubuntu 18.06 LTS, go there and do an SSH using, say, WSL or Bash, and you just need to install Black Scout. So Black Scout is actually all right. Okay. Yeah. Black Scout is actually an open source block explorer that you can deploy to any EVM supported blockchain. So it supports Ethereum, it supports Quorum, and other form of blockchains. So this is how it looks like in action. All right. So what this means is basically you'll see the blocks, which are what's happening across the whole network. So why does it matter? Okay. To be honest, the only reason why it matters is that, say, politically speaking, or again in governance, say you have 5 members, and one of those 5 members wants to go out, or or they want to add a new member. So what happened to the records? Well, the whole concept of blockchain is that it's immutable, so the record is still there. So you can participate, you can come in, come out, but the whole trading still happens. So that's why, that's where the niche market of blockchain is. You want to have a record that kind of like different members wants to participate and wants to collaborate. But then if they opted out, everyone who are still participating in the network still has the same copy of the ledger. And they still, have the copy of these blocks. And these blocks basically is the series of transactions that had happened, regardless of anything. Creating a new smart contract, transferring assets, and all of that. It's all recorded on the blockchain. All right, but the problem, that the whole concept of decentralized identity and the biggest problem people have faced, including me, in understanding this whole concept is that people is not actually ready for this yet. It's hard to say that, as a end user, I don't need to trust the service. I just need to have an identity and I can do the transaction myself. It's very hard to empower the user for them to have their own wallet. Say, I need to memorize this Ethereum address, and that's my public identity. It's very hard. I mean, the concept is nice, right? And you get to memorize your one-time password and make sure no one actually knows it, or else that someone can now do transactions on your behalf. Okay? But the point there is the whole concept of decentralized identity is that your identity is not actually stored, say, on Facebook or on someone's database. You're actually using that identity in order to do the transaction. Okay? However, then there goes the enterprise use case, okay? So in the enterprise use case, we kind of waived, all right, we don't need individual people to manage their own identities. What if, let's use something more familiar or something more mature? And you guess what? It's called Active Directory. So what's Microsoft's focus now is, okay, people is not yet ready for a fully decentralized world. But maybe we can do a decentralization across different members of the organizations. Say, organization 1, organization 2, organization 3, right? So it's basically those organizations who are now the members. It's not the individuals who are managing their own identities. It's those parties, okay? And there goes their idea of creating the concept of Azure Blockchain Workbench, okay? Let's go to blockchain and let's search for Workbench. I have very mixed feeling about Workbench because in particular, it kind of deviates from my idea of a fully decentralized identity, which is something I really like. But the whole concept of Workbench is that, okay, the biggest problem is how do you actually bring that decentralized record into a centralized record, which is a database, all those stuff, Active Directory, and something that's beneficial for the business. So that's what Microsoft is trying to bridge. Say, how can I create a mobile app out of this? Or how can I create a chatbot? Or how do I actually, do transactions that people don't actually need to know their private keys, they don't need to manage their seed phrases and stuff like that. And that's their idea, all right? So let's bridge that, okay? Like on-chain, okay? So the word on-chain means records within the blockchain, that's on-chain. Off-chain is records outside of the blockchain, but are connected, okay? So the whole idea is, okay, on-chain wise, we're still using the blockchain. So the records are still persisted on the blockchain. That's on-chain. So that means that different parties can have access and power towards that record. However, off-chain wise, there are reasons why, company A would have certain records that are not relevant to company B. A very classic example would be client information. Right? So, because one of the key problems also that companies are doing is that they thought that, okay, the full decentralization means we need to put all the records on the blockchain. The answer is no. You only need to put records on the blockchain that are relevant across those different parties. Okay? So records that are not relevant, especially client information, it doesn't make sense to put it on the blockchain because of GDPR, KYC, and all those stuff. Okay? Because once it's on the blockchain, there's no way to remove it unless everyone agrees to shut down the ledger and create a new one. So that's something, just something to remember around that concept. All right, so kind of the same thing. You need to create resources, which is, say, Workbench. Let's just name it Workbench. Password. One thing you'll actually see here, there's a database password. So that basically means there's now an off-chain integration from the on-chain because we're now introducing a database. All right, same thing, you can choose a deployment region, say Southeast Asia, resource group. Let's just grade. All right, then in the configuration setting, you can create a new Ethereum network, just like what we did earlier, or you can join an existing network. So in this case, you just need to put the RPC endpoint. Okay, I'll talk about the RPC endpoint in a while. And there you go. You can integrate an Active Directory from an on-chain data to an off-chain Active Directory. All right. All right, once you have that, once you set that up, you'll have something like this. You'll have a lot of different resources, okay? just like what I mentioned, you now have an off-chain database, okay? So this database here, this SQL server, is tied in to the ledger, okay? So it's basically like a replication of what's on the blockchain, but it's a copy for that certain entity, okay? So in this case, Parramatta Cars, they own this SQL server, okay? So Bondi Motors doesn't have access to this SQL server, but the transactions that I'll show you later is actually something both of them owns. All right. So it comes with a SQL server. It comes with App Insights for monitoring. It uses an idea of key vault. It uses key vault in order to bridge the signing of transaction from an Active Directory user to an Ethereum private key. So they use key vault in order to make sure that, okay, person one is this Ethereum user. Right. You have a web app, and you have an API app, and a load balancer, and a test project. All right, so let's go to the web app, which is this, okay? So similar to what you saw earlier, but this one is say one step higher in terms of abstraction, okay? So the one you saw earlier, it's merely managing users or addresses and managing the power in the network. This one actually allows you to say, deploy an application, deploy a smart contract, and add members from Active Directory. So specifically, here I have a membership of me, and I added someone to my Active Directory, and there you go. That person is now part of this off-chain record, okay? So say the simple marketplace. Okay. In this simple marketplace, one thing you need to know is that I'll probably show you how to create this. So when you click on New, you need to upload the contract configuration. Let's say, sorry, presentation docs. All right, let's quickly open this. Let's see. There you go. All right. Also open. Okay, let's cancel that for a while. All right, you'll have something like this. The .sol file is a Solidity, file. This is the buzzword smart contract, okay? But what I'm basically gonna say is that it's not smart and it's not a contract. It's a state management mechanism of a certain address. Say in this case, if you're familiar with JavaScript or TypeScript or other language, a contract is basically like a class. Right. Then these are basically enumerations of different properties that you want, to be available. Then a public is basically, a public property. Then an address is basically the one I showed you earlier, the 0x ... etc. Right? So what we want to do here is that we want to have an instance buyer, an offer price, an asking price, description, and an instance owner, and a state. And a state is basically what a smart contract is. It does state management. So we want to make sure that, when item is created, so hence with the constructor, the state type is available. The item is available. Then we create a function, which is a make offer, accepting an offer price argument. And obviously we do some checks that it shouldn't be 0, and it should be available, and the instance owner should be the sender, which is the address of that user. And basically from there, you change the state from available to offer placed. Then eventually you can do a reject, and you can accept the offer, right? This JSON file, on the other hand, is something proprietary to Blockchain Workbench, because this actually allows you to map this smart contract to the workbench. Okay, this is basically just a bunch of workflows, etc. Right. So when we try to upload that, let's say, come on. Yep, checking the file and the Solidity file, and just deploy. And that's it. Your smart contract is now, deployed on the blockchain. And these records here are on-chain, and these are not off-chain. Okay. So let's try to create a new one. Say the description is limo, say 10,000. Right. There you go. As you can see, contract tree is being created. So, because this item is a smart contract. All right. If you look at here, all of these records are actually appended on the blockchain. Okay. So don't be confused. This is just a user interface. Okay. So no one is stopping you to create a different UI for this. But this is just a representation of the state management of the record. So the item is available as of this time. The details, all right? So what if, let's try and open this and buy this using my other account. Right. So this is the one with atredify.net using the Edge browser, and the other one is using the Canary Edge browser, which is this one. So in essence, they are of different directory or different tenant, okay? So let's just assume, for simplicity's sake, that the at Outlook.com is Parramatta Cars, and the atredify.net is the Bondi Motors. So the whole concept there is, they can interact on that smart contract, and in this case, I can make an offer, and my offer price is say $9, just making fun of it. Okay, so all right, so the item or the action is now being recorded on the blockchain. Okay, and when I move back here, say when I refresh, it's visible to me that the other member actually placed an offer of $9, and obviously, and that's where the whole shady part of what we're trying to solve here is using blockchain. That the record is immutable. You have the record that's not being owned by Bondi Motors. It's being owned by both parties, and we have the record to show that someone is doing an anomaly. Okay, and obviously I'll take an action, and I'll reject the offer. All right. All right. Okay. Now I'm gonna make the right offer this time. Say I'm gonna pay a penalty and a fine, so it's now 12,000. All right. Let's accept that.
What's happening
During that time, that's when the record is trying to be propagated across those 4 different nodes, right? So remember, in order for a transaction to be valid, the record should be available across those 4 nodes. It's not as simple as just inserting to one database of someone's database. So that's why the reason why it takes some time is because all those 4 nodes needs to agree that this transaction is valid. Okay? So that's why it kind of makes sense. It only makes sense to use blockchain if there are different members involved. Because if this is your use case, and there's no difference of just using a database if there are no other parties involved. But in this sense, you don't maintain 2 separate databases and compare them eventually. You now have one decentralized record that's being used by different parties. All right.
What happened, you touched on this private database. So if you somehow have sensitive data is actually stored in the private database, primary cloud, how you actually, if you want to populate that data into the contract, how do you do that?
Sorry, could you repeat, please?
Private database, how you actually populate that data into the contract, including the contract.
Okay.
For instance, like a car manufacturing details. So that is in the local database, but like the private contract, that would be important to include a contract so that you can be kind of like a sensitive group for cars itself.
Okay, could I go back to you because I only have 10 minutes left? All right, I'll get back to you, promise. All right, so next part is, now we're touching the off-chain database. So since this is, as part of Azure Blockchain Workbench, they have an orchestration in order to basically sync the on-chain record to the off-chain record. So in a specific scenario wherein I don't want to expose, say, the manufacturer details and stuff like that, it kind of probably makes sense to put it on an off-chain database that's being managed by specific vendor. Or maybe who are the clients who are interested on this. There are many use cases around this. But basically, what I would like to show is that it's a database. And let's see if I can connect. Or maybe not. Okay. All right, there you go. And there you go. You have different tables that actually corresponds to those, related on-chain to off-chain records. So say application or contract. Let's select the top 1,000. Yep. There you go. So you do have the copy of the record. And you actually map that to say what's the workflow name and stuff like that. All right? But not to be confused, this is not the source of truth of the blockchain. This is just a record of the chain. Okay? So why stop there if you can actually say do something even funkier, which is say create logic apps. So with logic apps, you can probably automate this and say, why not use a chatbot, say Alexa. Okay, so from Alexa, you can basically create or insert a new record to the blockchain. Right? So here's Alexa. And yeah. And I can sell an item. I can actually train Alexa to actually learn the utterances of selling an item and what are the different utterances and different, intents that I want to do. So in this case, say, this is a simulator. What I said is basically ask Ignite. Okay. So basically, that's just it. You can do an orchestration from Logic App, Alexa to blockchain workbench to on-chain data. That's just what I'm saying here. All right, but why stop there if you can actually, have an API? So with an API, you can do, say, a mobile app. And the same experience, or maybe customized, You can use your Active Directory as the login without maintaining an address in order to use the blockchain records. Right. And kind of the same thing. But the whole concept around here is that what Microsoft is trying to bridge is that how do you bridge that on-chain record to off-chain to something like mobile app or web app or something like that, or using Active Directory as the mechanism. And that's what Blockchain Workbench provides for you. Okay. And lastly, why stop there? Wherein you can actually use Power BI to make sense of that record. So you just need to connect to the same database, okay, and use, say, create a table. Yep, create a table and say block hash, application name, transaction form, transaction hash, transaction 2. And in this essence, this is something that brings business value to the business because okay, there are different members trying to participate on the blockchain, but still I have control of the records that are relevant to me. So to end it all, so just to recap, basically, any Ethereum node can connect, okay? For as long as they follow the same algorithm, and they are connected on the same RPC channel. So the RPC channel is basically the member ID that you created when you started creating the Ethereum network. Right. So in a wider scale scenario, you'll actually have, say, 5 to 6 members having their own different, Azure subscription, their own different resource groups, and they're gonna be connected on the same RPC channel. And this Ethereum node is connected, say, to Blockchain Workbench or to, say, any off-chain integration so that they can actually, facilitate that record. So that's like how people, that's how we actually use it, right? And what basically Azure Blockchain Workbench does is, all right, so you have the Ethereum node, you're kind of bridging that Ethereum node to, say, a client app, say using Active Directory, an off-chain SQL server, an API app, or a logic app, application insights, and whatnot. All right, so in summary, it makes sense, and it will only make sense to use blockchain if there's a trust gap across those different members, because if they do trust each other, it doesn't make sense to use blockchain. They just need someone to maintain a database. And Azure provides templates, and Blockchain Workbench gives you the scaffolding or the pattern. So my time is up, but if you want to learn more, basically this is just the list of resources you need to look into, and that's pretty much it. So if you have any questions, feel free to.
Have you got any examples of systems you built already that uses technology?
I can explain to you what we did. Unfortunately, out of those 12 projects that we did, only few of them were successful. Actually, only 2 of them were. One in particular is the concept of asset management across different government entities in Queensland. So we are we actually use blockchain to do a proof of transfer from one entity to the other. So in order to do that, there are different parties involved, such as the telco provider and the handset manufacturer and the government bodies and different form of state management, wherein it needs to be approved, it needs to transfer, and change of states, all right? And we use blockchain in that specific scenario wherein, all right, those different organizations kind of agree what's the current state of this asset. Who owns it right now, or who's actually in charge of this, or who's actually maintaining this, and who's going to be liable for this. If, say, something goes wrong, you do have a record to show, okay, this person is the last person who used this, and it's not being tampered, and it's already visible across those different parties, all right? The government body doesn't need to ask the telco provider, what's the current location? Or, doesn't need to ask the handset manufacturer, what's the current status? And stuff like that.
What's the key vault? Using in the workbench, you're using the key vault. What's the use for? How we actually use it?
So the question was around what is key vault and where do we actually use it in the blockchain? So we use key vault in order to map the private key of Ethereum into an Active Directory user. So that this Active Directory user is basically like impersonating this Ethereum address, wherein they're using the key vault to store those private keys. And so that this Active Directory user can do the transaction on behalf of that Ethereum address, which is basically that person in theory.
So what about the private blockchain? So you touch on all these, unlike the public, all the sharing, same data. What about private chain? So that's actually the concept. How we
So the question was around private chains or the private blockchain. I, for one, doesn't believe on a good use case of a private blockchain. Maybe a distributed ledger. So, and also it's another opinion. Say R3 Corda or REST chain or other form of blockchain, which doesn't actually have networks of different members participating. For me, they're not blockchains, they're just distributed ledgers. And distributed ledgers is basically just 3 different records or 3 different storage wherein they share the same record. And they're just distributed so that, when one record fails, the other one is still available. And but then the authority around it is still managed and still governed by one central body. It's still owned by one, member. So that's why for me, a private blockchain doesn't really make sense, or it's not a blockchain, because in order for it to be a blockchain, there needs to be a network. All right, thank you.
Thank you.
QR code.
Did I send you a QR code?
What QR code?
It's all right.
All right.
It's fine. I will sort it out for you.
Okay.
All right. Give me 2 seconds. I'll get it up for you guys to get some feedback. Did anyone ask you some good questions?
Yeah.
I've got an Azure bottle to give away. The best question you choose. I wasn't in the room. Good bottle.
I would say the best question was around the key vault and the the off-chain, on-chain record.
All right, thank you.
Thanks for participating. Well, we still have 7 speakers for the day, so you still have 7 out of 35 chance to win.
Is Simon coming back with a QR code?
Maybe. I actually
I'll
don't
just
know.
set up. Check.
So we won't kick the next session off until 10:15. So feel free to mill about, ask questions, grab a coffee, and we'll get started at 10:15.
Hello? Hello? Awesome. Maybe I'll start with some questions. How many of you have used logic apps? Show me your hands. And let's say wrote, how many logic apps have you wrote? Or I just play with it or have it deploy in production? How many have logic apps deploy in production? Oh, good, good. Why are you in this session? No. That gives me stress. All right, good. No problem. And how many of you have played with Azure functions? Azure functions? So serverless technologies like Azure functions. Okay. And have it in production as well? This is the same hands. Okay, good. Excellent. My code works.
Yeah, no, it's fine. I'll give you a short one. Then it'll work for everybody.
Yeah, but my code works.
I'm going to give you a short one.
They've already given me 5 stars.
I will check the responses to see when they were entered.
He lies. He never checks anything. That's also not the link to the. Did you just want to add a new link? Oh, okay. Let me get some water. So Simon's left the room. I'm just going to start. Okay, cool. Thank you for coming to my talk. My talk is on logic apps and Flow. When I say Flow, I mean Microsoft Flow. It's a product from Microsoft. Rather than say, if you're from the JavaScript world, you might be familiar with a different Flow product called Flow Type. That's from Facebook. So logic apps and Flow for developers. And this is usually an hour session. We're going to condense it. But really, it's to show off the type of solutions or techniques that you could use to build logic apps and then integrate that into your overall solution. So a little bit about me. My name is John Liu. I'm actually from the Office side, so Office 365. I'm from SharePoint. I'm also a Microsoft Flow MVP, from SharePoint and Microsoft Flow MVP. My background, I've been in Sydney for about 20 years now, being in the .NET user groups, being heavily in Azure, in SharePoint, Office 365, Flow. Yeah, lots of events. You can find me on johnliu.net. You can find me on Twitter, John N. Liu. I can't get the one without the N in the middle, because that's an ex-Twitter employee. I can't kick him out. And also, I've started working on my own SaaS app called flowstudio.app. Right, so the plan for this 1 hour condensed to 45 minutes. See, initially I thought I have 10 more minutes, but apparently that's your morning tea time. So you just have to go without morning tea. It's kind of. All right, I want to review what it means what we mean when we say serverless with the quotes. And then understand that aside from options like Azure Functions, where you have to write code serverless, there are actually low-code serverless options. Right? You can run serverless without actually writing much code at all. Then most of this talk is actually just demos. And then I want to basically wrap it up when we talk about where are the tools going, where are we going as developers. I assume most of us are developers of different experience. And then where are we all going, the direction of where everything is going. Both the tools and where maybe we should be focusing our skill set and learning as we move along. Okay? But first, I need to get you super excited about Logic Apps and Flow. So very quick review. When we say serverless, usually people mean consumption pricing. It means I want to use the cloud, right? I want to use Azure or AWS. And if I am not using anything, then I don't want to pay for it. I don't want a VM running there, eating out all my credits when I'm actually not doing any compute, right? Like we kind of understand storage. Look, if we put stuff in blob storage, there's a hard drive somewhere spinning. So yes, there's a minimum storage cost with storage. But typically with compute, the way we see serverless is, hey, if I'm not doing any work, I don't expect to pay anything, right? It's like electricity. If I don't turn the lights on in this room, I should not be paying any electricity, right? That's kind of how we see it. Because Azure Functions and AWS Lambda, they were almost the first products out the gate that really pushed the serverless concept. A lot of times people think serverless means function as a service. It means you're writing some sort of code that warms up, runs, and then shuts down. Some people equate this. I want to kind of expand that serverless definition. I forgot what I mean when I write that, so I'm just going to skip it, pretend you didn't see that one, I don't know. Okay, so this is the story of a developer. His name is John. He's actually, this is kind of just my story, really. So I was doing ASP.NET on-premises, IIS code. I have to write code to talk to SharePoint Online Office 365. Microsoft will not run my code, and it's not because it's bad. It's just because of the SLA, they don't want to run anybody's code. So there was a time where products are on premises. I could write code that injects into IIS and do whatever I want. And then in the cloud world, Microsoft says, get out, go away. Get away from my server. So they kick us all out. So what did I do? I spent 6 years writing code in JavaScript. Right? There's actually a little asterisk here. Do you know what else I was doing in these 6 years? I was, anyone did Silverlight? Crying? Anyone do Silverlight? Yeah. Right, okay. So there was a time I thought, okay, my C# skills could be wrapped into this really crazy engine called Silverlight, and we're going to run in the browser. That died pretty quick, too. And then Microsoft released Azure Functions. So as soon as I saw Azure Functions as a way to run code in the cloud in a consumption model, it fitted really well. So I basically went from, imagine I'm doing ASP.NET, skip MVC completely, because I wasn't doing it, I was writing JavaScript, right? And then this is when I did all the Angular stuff, and went to Maliki's user group to talk about Angular. And then Azure Function came along, so I basically skipped right into here. Okay, I don't know where is your developer journey, but this is mine. And then, so in 2017, I have armies of functions at my command. It's like, I want that, let code be run in the cloud, and it just magically runs. And then when I check my Azure bills, it's $2.12 per month. I thought that's ridiculous. I'm running thousands of this stuff. Obviously, I'm not running more, so I wrote even more code. They are serverless, and complex ones start to get messy. And then I realized that I need some sort of orchestration solution. So the idea is that if you have a simple trigger that needs to update something, that's easy. But then you start to think, what if that update fails? What if the server is really busy? What if you want to retry? So you start to think, okay, I need some sort of system that wraps around these individual server endpoints and provides some sort of orchestration. Okay? I think this is, if you're writing more and more Azure functions, everyone goes down this journey. You start out, wow, this is so cool, so easy, write 1 or 2. And then when you get to 20, you think, when that fails, I really don't want that to run. So I need some way to figure out how to link that, you know? And then let me take a pause and look at someone else's journey. Peter Sabatsky, he's a guy based in Melbourne. He runs a company called Cloud Guru. And back then, when I was learning serverless, I thought, okay, I need to go and read what the serverless experts at the time, 2017, and what they wrote. So Peter Sabatsky, who happens to be an Aussie, he's down in Melbourne. He's been doing it for about 1.5 years by then. And he wrote books and built a whole company around serverless. I think he runs a serverless user group both in Melbourne and also in Sydney. But I don't know how often he comes up. So in his serverless kind of book, that was one of the earliest books on serverless, and he put some definitions towards what it is. He says, first, use compute service to execute code on demand, very much AWS Lambda and Azure Functions. He said, write single-purpose stateless functions. So don't have functions that do 1 billion things. Just do, simple things. Design push-based event-driven pipelines. So this is relating to how you link them. And then create thicker front ends and embrace third-party services. Okay, so this is his five points. This is something that someone wrote in 2015-ish about where he saw the future was going. And I read this and I thought, I actually really agree with this. But then I kind of look at what I was doing. I was kind of doing this. I was sort of doing this, and I was a little bit doing this. So I give myself 2 out of 5. I was not doing any of these other stuff. 2 out of 5. And I wanted to look at this point, which is the third one, which I was starting to do, right? I was looking for this orchestration solution. Design push-based event-driven pipelines. So in my kind of pseudo code, imagine you have some sort of source event. It could be triggered by a person submitting a survey, like when you're going to give me 5 stars. It runs a function. And then because the function is designed to be small, the idea is that when this function finishes, it puts a message into a queue. And the queue triggers the next function. Okay? And if this function were to fail, this queue will not be empty, so the function will rerun. Yeah? So that's typically the pattern that I see repeatedly in his book at the time. So he's using Lambda, he's using Lambda, but I was using Azure Functions, and we were doing the same thing. We put messages into the queue, and the queue, because of its fallback mechanism, it will automatically do retry, and that's how I could chain all my functions. Okay, that's what we were doing. So that was some sort of orchestration engine. And then it turns out everyone needs an orchestrator. So from Microsoft's side, we have Logic Apps, and Microsoft Flow came later. But I'll show you very soon what they are and why I see them as the same thing. Azure Functions now has a component called Durable Functions. Has anyone played with Durable Functions? Good. Where are the people who have Azure Functions in production? You should be using this. Right, so Durable Functions came out GA this year. I believe GA this year. And there is a code way of doing various orchestrations using Azure Functions. So Azure Functions, with writing code, it magically creates queue in the back that you don't have to worry about, and then maintains that state. So you can even do stateless functions, but then persist a certain state using this framework, and then bring it back in the next step. Right? So that kind of, all that really magical stuff, and abstracted away into an SDK. So as a developer, you don't have to think too much about it. AWS also has done some work. They're a bit behind Azure. They have a product called Azure Step Functions. And I simplified that thing. So instead of doing our own kind of orchestration, we have our event, we trigger some sort of orchestrator, and we put all our code in it, and then we finish. Okay, so that's where I saw what everyone was building. So on the Azure side, there's a person, Jeff Holland. Jeff Holland is actually on the Azure Functions team now, so it is a bit low. He used to work in the Logic Apps team. I think he was actually in Sydney a few months ago, and he gave a talk at the Azure user group. Oh, some people nodding hands. You might have been here. Yeah, extremely funny guy. I follow this guy, Jeff Holland. Because his background comes from both Logic Apps and Azure Functions, he is actually very well versed in this space. Like, how do you orchestrate your functions? Where's the strength of Azure Functions, and where is the weakness of it, if you can think of it? And then where is the strength of Logic Apps? All right, let me have enough talking. Let's go into demo, otherwise I'll run out of time. So the very first demo I want to show, is this is my Azure. And I have various Logic Apps here. There's a test LA and test request. So if I bring up the Logic App for test request, let me just go in and show you what it looks like. So Logic App has both a code designer, which is JSON based, and you're really looking at the definition of the Logic App, but it also has a kind of a visual designer. And you'll see that there is some sort of trigger. I've actually turned this Logic App off. That's why it's saying it's invalid. Oh, I'm not doing anything funny in here. So there is a trigger. I'll show you more of this when we go in the future demos. But generally with the Logic App, there is some sort of trigger. In my case, my one is supposed to be a SharePoint trigger. It triggers when there's some entries being put into SharePoint. You can easily find HTTP request triggers. So essentially your Logic App becomes a web service. When someone calls your endpoint, it triggers your code. Kind of like Azure Functions as well. You can use Azure Blob Storage or Azure Queue or table. They all have triggers. And then when the trigger happens, there are various constructs. This is for each construct, it can loop through elements in an array. I haven't set one up, so this is empty. And then there are some actions you can add. So this is how you can add new actions. The Azure Functions Azure Logic Apps has out of the box about 250 connectors. So if you wanted to say call, I don't know, Trello has connectors with a whole bunch of triggers and no triggers. Yes, there is triggers. 2 triggers and a bunch of actions. Or I think there was a SMS. There's several SMS providers. So if you wanted to send, say, a SMS via Twilio, or you could just take that, send an SMS. Okay? So in Logic Apps, you can imagine, I don't actually have a Twilio account, but you can imagine in Logic Apps, if you want to respond to an event and send an SMS to someone, it's literally 2 blocks. Right? You don't need to read any SDK, you don't need to authenticate, you don't need to cache the credentials for that authentication, and you only pay for it when it executes. Okay? That's Logic Apps in a glance, I think. What's another quick example? Another quick example I'd like to show is here. In the settings, so for most actions, there is a settings. In the settings, there is a for each construct, there is a concurrency control for parallelism. So what that means is this action will actually run 50 subtasks, up to 50 subtasks at the same time. Right? So imagine that my SharePoint list or my Azure, say my Azure SQL, I fetch the latest 50 records. You could feed 50 records into this loop, and every action inside will run simultaneously. Now imagine your Azure function just split into 50. And then the magical part isn't splitting out, because for Azure functions, split out is quite easy, right? You just pop 50 records into a queue, and they all spin off 50 executions. That's the fanning out. The hard part in any serverless work is the fanning back in, right? It's easy to say, oh, here's Swifty, and off you go, and you don't know who is successful, who fails. You don't know the order that they finish in. You want to then keep a separate queue, and then as they finish, they're gonna put a result back into the queue, and then you have to collect that at the end, make sure you got another 50 back. In logic apps, that's completely abstracted away. This action runs when these 50 finish, right? So the fan-in becomes just a box. I think until Azure Functions came out with durable functions, this was actually really hard to do. Like I could, back in 2017, I could fan out, I could not fan in. So I was doing work mainly in SharePoint. People will upload a whole bunch of documents. I was adding metadata to them, and then I was shipping them off to different project sites. Like these documents going to that project site, these documents going to archive, so on. And when everything's finished, I wanted to send an email to say, hey, here's a summary of all the jobs. That email was so hard to do, because you don't know when are these jobs finished, and it's probably, part of it is related to how SharePoint works. When SharePoint realizes you're just completely spamming it by one account, it starts throttling that one account. So it's one of those things where you're like, oh, you can call this endpoint and it works all the time until you parallel it. Then it works some of the time, and good luck, kind of. But within logic apps, the fan-in, the automatic retry, they're all in here. Let me go back to, I come from the Office 365 side, and in the Office 365 side, and Office and Dynamics side, there is a Microsoft product called Microsoft Flow. And I wanted to just show you what a flow looks like. Let me get my paper now. So this is the interface for Microsoft Flow. And if I show you the design interface, you'll realize, hey, it's completely the same. It's actually because both Microsoft Flow and Logic Apps, they share the same engine. In fact, they share the same designer. Okay? Anyone use Microsoft Flow here? Oh, okay, a whole bunch of hands as well. Good. So in my talk, I will use most of my demos are done in Microsoft Flow because I get free runs from the Office side. But I would say, I don't think I have a slide on this, but I would say if you're thinking, hey, what's the difference and why would you choose Logic Apps or Flow? Think about it more as if you have access to Azure subscriptions, then Logic Apps would be easier, right? A lot of Flow is designed for the end user or the power user. It's actually very difficult for them to go to IT and say, hey, give me an Azure subscription. And they're going to say, oh, how much are you going to spend every month? And they're like, I don't know, right? Because it's consumption pricing. You don't really know until you run a couple of months. So sometimes it's really difficult for a power user or end user who wants to automate their tasks to go to their IT and request a subscription. So for them, and also because Microsoft Flow, there is a bunch of free execution runs. There's about, in Office 365, there is 2,000 runs of any flow, so all the flows combined, per user per month. And it is pulled together for your whole organization. So if you have, say, 100 people in the organization using Office 365, that's 200,000 runs of flows across your whole organization, and it renews every month. So how many of you have Office 365 in your org? Okay, well, you guys have a whole bunch of free compute you're not using, and send me an email, I'll use them for you. That's usually a good funny one. Okay, so I want to quickly show a few more things. And then, sorry, on the Logic App side, because it is deployed through the, so Logic Apps is more focused on more integration scenarios. If you think about integrating with BizTalk server, and in fact, the whole, there's a separate Azure integration product, which links onto that side. And Flow does not take care of that. So Flow is more targeted towards the end users, probably stopping at the developer, and then the logic app starts on the developer and goes towards integration. Okay, so if you want to see it. I think as developers sitting in the middle, especially if you have access to both Azure subscription and Office 365 entitlement, your choices are fantastic. You could look at both sides. They could call each other, so a logic app could call a Flow, Flow could call a logic app, if you wanted to do those things. Yeah, okay, let me come back to here. So in this first demo, I am showing a flow. So this flow is a manual trigger. It just means I could just manually start this. And I'm actually gonna read, so this is a quick workflow, approval demo. And I want to start off with Gimli. So this is my test tenant, and all my siblings, all my minions are from Lord of the Rings. Gimli actually has to report to Gandalf, and Gandalf reports to me. I don't know what that makes me. So in this little do until, I basically say wait until approved, so it's false to start. I want to keep going until true. So in Logic App, there is a zoom thing. Let me see if I can just zoom this. The diagrams could get extremely wide. This is also why you need to buy a service hub. Ideally, the 4 lines side by side. Those are great for your Logic Apps work. So basically, I want to get the manager of this variable, so this Gimli, and then I will start a human approval. This will send an email and say, please approve this task. I've set in the settings here, there is a timeout duration, so I make it really short, 1 minute. Okay, this is a period of no dates, so time of 1 minute. And what will happen is, if the approval does not happen within 1 minute, it will fall into this ... branch. Okay, so in a sense, it's almost like building try and catch blocks. Right, do this, but if a time's out, go in here. If it's successful, go in here. So here it will set approve to true. Here will actually set, what does it do? In here, it will actually set the person, so this user variable, now to this manager, so to Gandalf. And then it will loop back. Okay, so this loop is actually a kind of a approval escalation, right? Like if you send approval to your team member, but he sits on there and he doesn't do anything, and then he goes on holiday, then he goes to his manager, okay, automatically, when this time's out. That's just an empty block that catches both, because I wanted to finish successfully, and then it finishes here. Let me bring out my phone, because the Flow has a, I'm breathing into this. Flow has a mobile app, works on Android, iOS, and I believe Windows Phone. But I don't know if they're still updating it, the Windows Phone one. So I'm just gonna run that. So that could be another differentiator. Logic Apps does not have a mobile phone. Flow has a mobile. So you see, there's 2 parallel branches happening. The left-hand side starts an approval, which should tell me anytime soon. And then the right-hand side is actually going to wait 1 minute. There should be 2. There should be this one, and then there should be another one. I'm just surprised it's not happening. What's going on? Oh well. My Flow app does not have enough coffee. So this side I have to wait for a whole minute, because the first loop is waiting for Gimli, but he is, what trouble did he get into in Lord of the Rings? Oh, no, sorry. Gimli needs Gandalf's approval. Gandalf is stuck on top of a tower, that's why. So here we go, approval request is received. Approve this, confirm. Now I don't know where, yeah, see that one. So I don't know who, I forgot where I sent that approval to, obviously not me. But then in the loop, you could see it's looped 2 times. The second loop, it went into the success, and then it came out. Okay, so in Office 365, we do a lot of human approvals. That's why this is here. But if you think about this whole problem as an automation problem, this is just a really slow process, right? A human, just a really slow machine, right? So when you're doing workloads in Logic Apps, you may not be talking to humans. You may be just talking to an external system that takes several days to respond. Maybe they need to go and process, sum up a whole bunch of files, and then send that file back to you. So in Logic Apps, this orchestration would just go into a waiting pattern, and then they do not resume until they come back. In fact, you're not charged for all this waiting. So it will just sit happily and wait for you, and you're not charged. So if you're building this in Azure functions without durable functions, you end up doing a lot of silly hacks like trying to make your Azure function keep running and then paying for that runtime because you're kind of waiting for that external system to come back to you. So some of this goes into the higher level, the orchestration area. So this is a crazy example of approval, delays, loops, parallels, and the fan-in, which didn't work because I don't know who I sent that to. But yeah, that's the first demo. Now let's see. Second demo. So my second demo is, I'll just talk while using my mouse. Again, a manual trigger. But what I want to do is now I want to read my calendar. So I'm using the Outlook connector to read my calendar. I'm actually pulling out today's date. So start of UTC now, convert that to Sydney time. And then I'm basically looking for an event, the first top 1 event that started after midnight this morning. There should be one because I'm in it, the Azure Bootcamp. And then actually, let me just show you what I did. And then what I'm doing is, this is an example where I'm actually using Logic Apps or Flow here to generate new content. So a lot of times we think, oh, orchestration is you take an existing file and then you send it to a new place. You take an existing record and copy it to a new place. This is an example of me essentially creating new objects. Okay, so I'm using an action called compose. Compose, you can think of it as a very generic kind of a string builder. So you're just building a massive string. I want to build an ICS file, which is an iCard. It is a calendar invitation card. And it's actually a very old format. So it kind of looks like this. It's got begin, vCalendar, and there's a D timestamp, and then there's a time start, time end, and then there's a summary. So I'm basically pulling values from my event, creating this big text file. And then I'm going to send an email to both myself and Gmail. And I'm going to just stitch this text file right into the content of the attachment. Okay, so if I send this, runs very quickly. This is all done, all 0 seconds. 0, I think sub 1 second. It's like 0.0 something. Where can I see it? There we go. That's my iCal. Oh, no. Why do I? Are these important messages to me? My God. So the Azure Global Bootcamp is in room 2. And it's a whole day. Yeah, a demo meeting. Oh, sorry. Let me turn that off. Now everyone's reading all my emails. What is there a good way? There's another one. I also should, yeah. So that's that one. So really quick way of generating text files. And then just throw them into attach and say, go and send that email. And that's done. All right? I want to ask a developer, how long does it take to build this in code? Can you give me your best? Huh?
You make it work.
Depending on whether you figure out how to authenticate first, right? Like, do you know how to talk to a calendar? And do you know how to send an email? And then maybe you have to fiddle with a bit of string to binary to do the attachment. Other than that, I think this one is not too bad. But you can already see there's so many things. If you have the out-of-the-box action, maybe you don't need to learn the code or figure out how to auth and all that stuff. That's the second example, all the fun stuff. Next one, I have this funny one. So this one is a bit more involved. This one, I'm using a HTTP request trigger. Let me just quickly see it. Yep. So HTTP request, you can actually define which method. By default, it is a post. So I'm going to copy this. What is everyone's best tool? Postman. I run Postman to prove I'm still a developer. So while this loads, I came to Logic Apps and Flow because I was looking for that orchestrator. Remember, I have hundreds of code in Azure Functions. I needed an orchestrator. And then once I found the orchestrator, I realized it has all these actions, so I don't need to write all this code. So my story went around the other way. Like I go, oh, you mean I don't have to maintain this code? I don't have to remember credentials because the Logic Apps and Flow has a connector framework that does caching. So it automatically knows when your token has expired, and it automatically go and fetch one for you and use it without you ever having to worry about it. It just goes and does it. So wonderful. The less stuff a developer has to do, the better. All right, we're going to paste that in there. It's going to be a post. And before we execute it, let's double check this. Okay, what are we doing? I am using my SharePoint action again because I work in SharePoint. But I pull out a JPEG. So this is embed all the things JPEG from my SharePoint. Do I have it? Yes, I infer the content type. But it's basically going to guess from the JPEG. It thinks, oh, it's probably an image. I use an expression in Logic App. It's called data URI. It basically turns the binary into a really long base 64 string, extremely long. Not for humans to read, but perfectly for machines. Then that one is just a log. I wanted to check the 50 characters. And then I do this bit. This bit probably could be done easier. But I'm creating a file this is the OneDrive connector. I'm using OneDrive to create a file. I just call it .html. I'm concatenating a HTML tag, beginning and the end, a hello header, and then the image tag with the source set to this base 64. So remember, base 64 is the encoded base 64 string, super long. But I'm basically embedding that into the source. So imagine this HTML file is now a couple megabytes long. It's not for humans to read. But this is a good way for me to embed a picture. And then I'm using OneDrive because OneDrive has a method called convert to PDF. So I could just say, convert that HTML file to a PDF, please. And this action actually returns a binary. So I'm returning my HTTP response. So remember, this whole thing is a web service. I'm going to request it. It will go and talk to SharePoint, generate my HTML, convert to PDF, and send it back out. Okay, so the response is 200 with the binary content. All right, and then if I come here, now how do I do this? I'm going to try just do this. Could not be previewed. Let me do it this way. Send and download. Yeah, there's a download button. So basically, the responses came back, and it's called response.pdf. I'm going to save it to my desktop. Here we go. So that's my header. That's the big image. In fact, I stitched it in there twice just for laughs. And that's that. Now I need to ask the developer, how long does it take to do that? Convert the PDF and do some base 64 encoding and put the file out of SharePoint and make that whole web service. In fact, if you're building a, say Maliki, if we're building a, I call you Maliki, is that how I should call you? Yeah. That's your Twitter name. Okay, good. It's not an initial with a certain, okay. Say imagine you have an Angular app and you need to generate PDF on the server. And most of your app is in the front end, but you just have a couple of endpoints in the back. This could be an endpoint that you call. You don't need to write all that .NET or Node.js code in the back. It's just an endpoint, right? You wrap that, put that in front of Azure Proxy or API management in the front, so there's a nice URL. You don't call that silly, crazy, insane internal URL. But that could potentially be your export method, okay? And also think about another scenario, right? I'm pulling content out of SharePoint. This is for laughs. But you could, say, pull out invoice records from your data source. So now you have a HTML table here. And instead of a haha picture, it's actually your company logo that's up here. So you're generating PDF, a purchasing invoice that you can automatically send to your customers, right? So everyone suddenly start laughing and start thinking. It's like, why aren't we doing this already? And then think about the option of you have these parallel approval workflows that are happening, and those start out by sending an email to the approver. So you can actually take a snapshot of the thing they're about to approve, generate PDF, attach it in that approval email, so when they see the approval, there is an attachment. It also acts as a kind of a date in time timestamp. This is the thing you're approving. It may change later, but you're approving this version. And when they hit approve, you run this again and take a new copy, new PDF copy of the document that they just approved. Copy that to a separate site. There's your record management solution, okay? I'm just here throwing out solutions. Everyone's just nodding their head. Here's another solution, here's another. Crazy. This is why Logic Apps is a bit insane. Also, as developers, we need to think, what are we doing? In 5 years' time, what sort of code are we writing? Think about that. All right, let's keep going. We're going to have more fun. I have 10 minutes, and then I have to let you guys go. What's a good one? I might show you this one. I won't show the code. I'll just show you what they do. So sometimes maybe there is no action. Maybe Logic Apps or Flow does not have the action that you need. In my case, what I'm trying to figure out is I want to, oh, there's a warning. Wait. Oh, yeah, okay. So I'm trying to talk to my Office 365. I'll show you what this is. There's a body. Let me look at this. Okay, so I want to show you just these two. So I'm using Compose to generate a JSON message. I want to know the resource, which is groups. So basically, I want to know when anyone in my company creates an Office 365 group. And if you work with Office 365, you know Microsoft likes to push teams. And they tell everyone to create teams, which is wonderful. And whenever someone clicks new team, it creates all these groups and all this stuff in the back, which the end user really doesn't worry about. But if you're from the IT side, you're like, oh, there's another Azure group, with policies on it, blah, blah, blah. So what they need is some sort of trigger that says, hey, I need an event to happen when someone creates an Office 365 group, anywhere. Whether they do it from Outlook, whether they do it from SharePoint, they do it from Teams, anywhere. In Office 365, you can accidentally fall over and create a group. It's just how easy it is to make these things. So I'm creating a JSON message. I'm after the groups event. I'm after the updated event. And there is actually a URL I want to call. This is actually another Logic app that I want to call, a web service. And then there's the expiration date time. In Microsoft Graph, all the webhooks has to expire in 3 days. I do not know why. It's kind of weird. But anyway, you get the maximum of 3 days and then minus 1 second, and that's what you get. And then here I'm posting to Microsoft Graph with this message. And then you basically need to provide a tenant ID, a client ID, and client secret. So these you register through the Azure AD register an app, and then you create that. So these two actions will go and call Microsoft Graph and create a subscription to your service, right? So it's a case of if you don't have an action, you can make them, and then that's 3-day expiry. It expires 3 days. Oh well, we're just gonna run this every 3 days. So every 3 days, this trigger runs. It's on a schedule. It just automatically resubscribes every 3 days. So I've had this running for probably, I have no idea how long. No, I updated it recently, but I had it running for years. So it's been running every 3 days for I don't know how long. And that's the first part. The second part is the listener. So the listener is a request URL similar to the Postman one that I showed. And that's the actual URL I use in the subscription. So 3 days, every 3 days, the subscription runs, we register the webhook. The handler, the callback URL is the second flow. So this flow gets called every time someone creates a group. Okay, and then you can decide what to do there. You could say, put that into a list or send an email to tell people, hey, this new group has been created, and so on. Simon's coming back. I don't know why. It's coming back. Oh, yeah. I have to. So if I go over, what will happen, Simon?
Sorry?
Can I go over?
Well, you stop people from having morning tea.
It will be so cool. They won't mind.
Well, vote of hands. Who wants to be impressed by John?
All right. I'll do my last demo, and then we may not finish the slide. My last demo needs a tiny amount of work. Firstly, the Flow Logic Apps uses a separate, this is a free download from Microsoft. It's called the On-Premises Data Gateway. It is used by Power BI, Flow, Power Apps, and Logic App for these products, which are cloud products, to talk to your on-premises systems. So the way the data gateway works is it establishes a private kind of tunnel into an Azure service bus. So all the cloud products go to the service bus, and then this agent runs it locally in your environment. You can run the on-premises gateway in multiple machines, so they act as kind of a redundancy fallback mechanism. I'm just gonna leave that running. Then the next part is I'm actually gonna run Minecraft. Okay, so this is Minecraft. This is not the Java version heavily modded. This is the retail version of Minecraft. It's mostly recently updated. While that's running, I'm gonna run one more thing. It's called Code Connection. Code Connection is an add-on to the normal version of Minecraft, which creates a REST endpoint for Minecraft. So Code Connection is mainly used by Minecraft education for people that are teaching kids how to program. Okay, so what they do is then they say, hey, connect Code Connection to Minecraft, then you get a REST endpoint for anyone to talk to Minecraft. And that allows all these educational programs that could pause Minecraft and then program the guy to walk like a robot, turn around, pick up, kill a monster, that kind of thing. So let me just not sing now. And play, go into my demo world. And I need to copy this. So this is why I need a service hub, right? All right, let's copy that. So we need to first tell Minecraft to connect. Oh. All right. But let me fix this. So when that flicker, you know. So code connections has connected to my local instance of Minecraft. This typically should be run by your teacher. Right? Your teacher starts an instance, all the classmates join, and then your teacher runs this, which creates the endpoint. What I'm doing, let me just explain, is Minecraft talks to code connection talks via the data gateway to the cloud. I'm going to call flow to tell Minecraft to do something. Where's my robot? There's a little robot. The robot only appears when you are in this mode. All right, I'm going to finish this. And let me go into this. So in this, there are a few actions. I'm going to wave, place the table, and hopefully place the cake. This is the part where I always hold my hand, hold my breath. Oh no. It may not be working. Do I need to restart this? Maybe I need to restart this. Hold on. This might not be working, which is very... Oh, there we go. Sorry. Yep. I think because I left it running last night and then I changed network, it probably disconnected from the service bus. So what I think happened just then is this put the message into the service bus. When I restarted this, it reconnected the service bus, started processing the messages. I think that's what happened. That's why I did not have to rerun the flow. I'm just trying to explain what I think happened. But what I want to show here, aside from just being a really cool demo, because I want to show Minecraft, is an kind of a crazy way of having the cloud reach into your on-premises, call a REST endpoint inside your network. Right? So it may be a file that you want to pick up from a network drive. It may be JSON or even XML web services that are legacy, but you want to now connect it to the rest of all these wonderful connectors that are happening in the cloud. So the on-premises data gateway lets you do that. And you can do that from both logic apps and flow. And you can also use it to call Minecraft. So I might just have one word to finish. I'm not going to do the slides. I'm just going to say, I think let me just come here. Yeah, let me finish here. So there are some more notes on the slides. Contact me either Twitter or my email, and I'll shoot that to you. Please give me feedback, 5 stars. Otherwise, some sort of bot will filter it out. We do run a Power Apps and Flow user group in the reactor, and that will be next Friday. It's a lunchtime session. So if you want to, we'll provide lunch. Come along. There is a app in a day. App in a day is Microsoft's free event to train you either in Power Apps and Flow for one whole day. So you do need to register for this, and it will fill up. This one I'm actually doing with Paul Comsey, coming over from Perth. So he's a Power Apps expert. I'm a Flow expert. We're gonna just make magic happen. Maybe with Minecraft. But yeah, that's pretty much it. So I think as developers, we should write higher value code. If you think most of your workload involves writing glue code, gluing application A to application B, I think it really helps you to really understand logic apps and flow, and potentially move away from learning this area. Like authentication to a system and then just doing some glue of APIs, that job may disappear. That's my view. These systems are now being built by humans. One day a bot will automatically connect a SQL table to an Azure table, and you will read the schema on both sides, and it will just connect everything. So I don't know what a developer should not be doing that kind of job in 5 years' time. So that's where I think we should be aiming to go. Let me just wrap that up. That's finished. Do you want to say anything?
No, big round of applause for John for that talk, please. Did you get any good questions out of the audience while you were presenting? Any good questions? I have a bottle here for a good question.
No, I didn't give her any chance to ask anything.
One good question, and you can win a bottle. It's a good bottle, trust me. Yes, gentleman at the back.
Okay, so the question is for Microsoft Graph. Is there an API to convert JPEG to PDF? The answer is actually maybe. So,
You stumped him.
No,
That gets the bottle.
No.
He
no,
couldn't
I'm not
answer yes or no.
I'm not stumped. I'm just saying it's soon. Microsoft Graph has a beta endpoint versus a V1 endpoint. Look into the beta endpoint. The convert has a lot more capability than this one. So this one is obviously calling graph under the scene. And it really does about 4 or 5 file types to PDF. The one in the graph, actually, no, I don't think it does JPEG. Sorry, JPEG to PDF. Yeah, it definitely does that.
So which API you were using in the
Convert is on the file object, so either OneDrive or SharePoint file. Okay, those in the graph, they are the same object. The SharePoint and OneDrive team is actually the same team. But one is consumer, one is enterprise. So
Okay.
the endpoints are the same.
So what we'll do is in just being conscious that we've got 15 minutes, in fact 9 minutes. There's some morning tea over on the side
Yeah, I'll
here.
keep
There's
taking
some
questions.
water. Coffee's in the fun zone out inside there. If you want to go and grab a coffee downstairs, you can. We will start at 11:15 sharp with our next presenter. There'll be another dev content in here.
Logic apps, like
Yeah.
it's good for push things, like when pushing something and calling something a logic app, that's a good idea. But if we have to call something, like we have to check some SFTP server for continuously if the file is available or not, is this a good idea to run there? What we can do actually to reduce error consumption?
Yeah.
Did it happen with that story?
No, no. Anyways, I'll go through the rest. So you probably day to day, you're just checking your Uber application, which is one of the most significant real-time applications. Google Map, when you're stuck in the traffic, you just try to see where are you and then what is the traffic. They're all real-time applications. Another category which is interesting to me is the applications which are adding the transparency and, increasing the fairness. If I want to be clear, like the stock dashboards or the auctions or the bidding applications or the voting. So it's not fair to not having the equal amount of data going through everyone.
Just need to sign in regarding
Oh, yes, sure.
accidentally turned off.
That's fine. That's it.
So,
Just like that to extend the screen.
Which one? The
remember the short film?
No, it's kind of resetting everything. Cool. Is it fixed? Maybe you stay here, then I can check. All right. So this is one of the most significant part for me, really. And then online gaming, and I assume you guys are into it as well. So it helps people get together and play. There are all and probably more things that I didn't mention. Do you think of any that I forget to tell? Something interesting for you as a real-time application?
Dating.
Which one?
Dating.
Dating, yeah. That would be in the chat, probably groups, and yeah, that would be. So, the office that I work is located in Martin Place, 5 building Martin Place. So we have a very beautiful and fancy concierge, and it is decorated with a big, beautiful flower bouquet every week. So every Monday, we just order a big flower bouquet, and then on Friday, they have to throw it out because it's getting, not live as it was. But since we are financial experts, they wouldn't waste the money. So what they do is just running a bidding every Friday at, I think, 10 to 2. And then they sell to the employees or people in the building. So you can buy 500 flower bouquet for probably $50, which is really good. What I do, whenever I participate, I just win. And people wondering, why are you always winning this bidding? And the reason is really simple, because the first time I just opened the website, I see, gosh, why it's not real-time application? You have to press the F5 all the time to see the latest price. And because I knew that, 2 minutes to 2, I just pop into the website and just press F5 and see the latest price that people bid the flower. And always I just add $1 to that and I win, because I knew that it's not real-time application and how it should be. But I was thinking maybe it's not really fair. So for this demo, I wanted to prepare something for this session, and I was thinking maybe it's good to have that flower bidding session, which add the transparency, really. What I need you to do, please, just help me and participate in this activity. Just pop into the website. You have the cards, and one side of the card is the picture of this flower. You can scan it, and you have the bit.ly on the card as well. Don't mind the other side. I'll show you later on. And let me at the same time open the website myself so you can see. Put your names when it asks for name, and you would see that it's saying your name joined. There we go. I can see more people joined. And just bid how much you want to bid. Put some dollars. $5. We have a staff in the concierge. He always starts from 20, so he doesn't let us go under that. Yeah. I'm using the free service of Azure, so I'm not sure how many of you can take this, but try. And the thing is that for this demo, which I'll show you how I made it and how it works, I used ASP.NET Core, Vue.js, and Azure Signaler Service. How many people so far? 6, 9, 12. You should more. 1,000, okay. Still more people going on? No, not mine. Minus 10. Simon, how I can see the switch the screen to the? I thought people are seeing. Okay, then I should bring it back to the extend again?
Yeah.
Okay, that's fine. Right, okay. Good participation, thank you. So, I assume it should be around 20 people. So nobody get the error message? No? Cool, okay. So I'll go through the detail and show you how it works, but just quickly, you can see a few things in my browser, which I just want you to remember the name. So you have the negotiate file and then some hub service here, which actually shows you where you're hitting, and you can see all the messages you're putting, the numbers and everything else. But we go through later. All right, let me get back to my screen. I extend it again. All right, cool. All right. So, just quickly want to tell you, I'm not sure how many of you really knows how the real-time application works and what is the technology behind the scene, but I'll quickly go through. So, the actual transport methods that we use for Signaler can be different range of technologies. So probably back in the days, people used polling and line polling mostly. Polling isn't really not the real-time functionality. It's more faking the real-time functionality. So it means that clients keep sending the request to the server and ask, hey, is there any information, new information for me? And if there is any, then server will send the update. If there is not, the connection will be closed, and then a new HTTP request will be raised. So you can see it's not performance friendly, because if you look at the network tab, you will see heaps of HTTP requests are raised, which obviously is not high performance. And the other thing is, it's not really online, real time, because it takes a few seconds to close the connection and open the connection again. So you wouldn't really see the actual data in a real time. One method better than that is line polling, which I'm not going through, but it's the same approach. Only the connection will stay a little bit open, for a short time, and after that will be closed. The other one is server sent event, which is the ability that server can push data client, but it's one directional and it's based on the HTTP again. The best one, probably the most efficient one, is the WebSocket. So WebSocket is the persistent connection between client and server, and it's bidirectional. So it's kind of full duplex, and it's not really based on HTTP protocol. So the protocol is different. It's WS protocol, WebSocket. And so the TCP connection will be established between the client and the server. And then as long as the session is alive, the information will be exchanging. Basically, it's just using the HTML5 APIs. So it's one of the features of the browser. So really it depends on the browsers of your client. That they're using the new ones or old ones, and if they support it or not. Examples are, as I told you, any kind of real-time applications, chat, bidding, or whatever. As a developer, though, it's not easy to use the WebSocket directly because you need to know socket programming, and you have to access low-level programming. So ASP.NET Core and Microsoft actually introduced a library, which is the Signaler library, and it's open source. So it's just migrated with ASP.NET Core and then ASP.NET. There are different versions. And under the hood, they use WebSocket APIs. So it's just kind of wrapping the APIs from the WebSocket, and it's just simplify everything for the developers. And the good thing is, if the client browser doesn't support the WebSocket, automatically it will fall back to the other methods, like polling, long polling, or whatever. The hub class is the heart of the Signaler applications, which wrap basically all the classes you need that client can talk to server and server can talk to client is just in the hub class. The good thing is you have two different libraries. You have a Signaler library for client and server. So you can, when you write the application, you can download both of them. How many of you have written this Signaler before? Cool. So you know that to write the real-time applications, you need a little bit different mindset. So you need to write server-side code and client-side code. And the reason is they both can communicate. I mean, client can make a call to functions method, and server can make a call to, I said function method, server method. And server can make a call, invoke any kind of methods in the connected clients. So it's bidirectional. Any questions so far? Is it clear following me? Good. Signaler and basically real-time applications with ASP.NET and Signaler works perfectly as long as your website is not hammered with loads of users, and it's not in the high traffic website. Once your website is getting into the high traffic, then the trouble will start, and you need to manage a lot of things. I assume you all know that why we need scaling out. So in any kind of applications, you might need a scale out. Once the users and clients are getting more and more, you definitely need to scale out your server. But with the Signaler, it's a little bit more difficult. So you need to manage a few things, which I show you what sort of things you need to manage. So imagine that you have a few clients connecting to your server, and you only have one server instance running at the beginning. Then the third client connect, and then your server needs to scale out. That's fine. So far, it's good. But the problem is, it's a little bit different from the normal applications. So in the normal applications, you just scale out, and this client doesn't need really to know the other clients, right? Everyone just connect, get the information back, and all good. But with the Signaler, the first client should actually know who are the rest. Because let's say I'm in the chat room, and I'm a client, and I want to broadcast a message to everyone, right? So my server instance basically should be aware of all other clients, all other server instances. is not something that you get in the normal applications. This is one of the troubles. To fix the problem, we use backplane, and the Redis cache is one of the favorite solutions for ASP.NET. It's more compatible. So it means that backplane is here to propagate the connection informations from the connected clients to all other instances. It's good, it's a solution, but it's not easy to use because you need to install Redis in your code, you need to pull the library, install it, set it up, setting the monitoring, activity log, and it's not really that easy for developers, so it takes your focus anyways. That's one thing. The other thing is for real-time applications to use appropriately, each client needs to stick to the same server that they initiated from. So if I, as a client, if I started with the server 1, it's better to stay with the server till in the whole journey. It means that you need to set up the sticky session. You need to configure the sticky sessions on your load balancer. So the load balancer knows basically where you start and stay you connected to the same server. That's another bit that you need to take care. The third problem, which is probably a big deal for businesses, is the cost. Why? The thing is, I talked about clients stay connected to the servers through the TCP connections, right? So it's not like sending a HTTP request and getting offline. No, you just connect it to the server and you stay in the server. It means that even if the clients are inactive, even if they walk away and then leave the computer on lock, still you have to pay for them because you have to keep their session, you have to keep them connected to the server, and then when the new clients come over, you have to scale out your server. It doesn't really make sense, right? So when your number of clients are getting more and more, you need really to pay a lot of money and go under a lot of cost for your inactive clients, which don't really add any value to your website. Other than everything that I told you, the other problem to me is, what if I don't want to use the ASP.NET Core or any web server application? What if I want to use serverless or Azure functions? Then how my clients should connect to serverless, which there's no really any server, like the stable server staying for a long time. What should I do then? Answer of all these problems is Azure Signaler Service. If you're looking for the high performance, high scalability, and high availability, using serverless and paying obviously less cost, that's the best solution. So what it does, I think it's launched last September, so it's fairly new product, and people are looking into it these days. So it's really easy to use and config. I show you, just maybe 2 minutes spending time in Azure, and that's it. And then it's kind of decoupling your connections from the actual application, the logic. How it does it, I'll show you, but just keep in mind that Azure Signaler Service is not like a backplane that I show you. It's more a proxy, which kind of redirect all your clients and offload all your clients to the new service, Azure service, instead of getting them connected to the server. But I'll show you in a minute. So this is the basic workflow. Connection is established. I mean, the client comes to the website, send the request, and ask for the connection, right? As usual. Normally, when it happens, immediately the connection will be established between the client and server. But with this scenario, it's not like that. So when the request comes from client, it's kind of just negotiation. There is no connection will happen. So the negotiation will happen with the app server, and then the app server redirect the clients to the Azure Signaler server. So immediately, they will redirect it to somewhere else. And then the connection will be established between client and the Azure signaler. And then the server will be free of duty. Oh, good. They can go, and then Azure signaler service basically knows everything. It's on the top of everything. It knows who came and sent the request, which server was, getting the initial request, and it tracks and keep every detail somewhere. And then the next step is whenever any request comes for actual data, the messaging or client send a message and then whatever, functionality needs, then the Azure signaler asks the app server to give back the detail or to send the messages or whatever. So the Azure signaler basically is responsible for all the connection details. And then the app server is just responsible for processing the data or whatever else. So it's basically your web server is now exactly the same as the other normal web servers, which is good. In the diagram, you can see that the client negotiates with the server, then the persistent connection, they redirected to the Azure signaler, the persistent connection will be established, and same for the server, so Azure is on the top of both, and then acting as a proxy. Clear? Good. I show you some steps to how you can really build the real-time applications. I have to go back to my Azure portal again. Hopefully someone here if I couldn't get back. Okay. This one, oops. So this is my Azure portal. Is it too small? Anyways, you don't need that. And you just need to search for signaler. And then you can see the signaler service. You just click the signaler service and then press add. Basically, it's what you need to do, that's it. The rest is just simple as usual. You just put the resource name like test, oops. You just put the resource name like test signaler service, and then you just choose your resource group. I create a new one, test signaler, maybe 2, and I put 2 here. The pricing, so I use the free one. It basically supports the single unit. Each unit is 20 connections with 20K messages. You can test the free version, and then if you like it, you can go for a standard one. So I select the free one, and then the location is just Australia. That's it, and create. It takes a few minutes to be created. So I already created one of the services here and then waiting for the other one. There we go. So you can see out of the box you have the activity logs, you have monitoring, scaling up, whatever you need from a server. What you need to take from here is just getting the connection string. That's it. So the connection string is this. I get the connection string and I put it in my ASP.NET Core application. So I'm not going through the code. I'll show you the highlighted important parts. But you just create your ASP.NET Core applications for the server side, for the web server, and you add this key in your service, and I'll show you in detail. Then you have your client-side applications, which I actually use Vue.js for this demo, because I searched and Googled, and I saw there's no Vue.js, so I saw it's cool to have Vue.js. And in the Vue.js, you just, this is the URL of my web server application, my ASP.NET Core. So you just ask your client to connect to your web server, and we will see what's happening. The cool thing that I'd like to show you, get back to the demo. So if you look at this, in the header, here. Yeah. So in the negotiate one, you remember I told you when the connection is requested, client will connect to server, right? So this is the actual URL of my ASP.NET Core. But the interesting thing is, in the response, you actually get back the URL for my Azure Signaler service. So it means that you send a request to your server, but you will get back the connection from the Azure Signaler. So you can see that it goes through the Azure Signaler now on. Let's get back. Hopefully it will get back. So, oops. Why I cannot see that? No one from. That's okay. How about I show you like this? Cool. So, you saw my application. So you saw that the first step was creating the Azure Signaler service. And it was easy, wasn't it? Just 2 minutes. The next one is building the ASP.NET Core project, which was, of course, you all know that. The third step is just, as I showed you, just injecting the signaler as a middleware to your ASP.NET Core application and use that interesting key to your service. If you don't want to use this Azure Signaler, then the traditional way was like just this, service.add_signaler. And the new way is just adding Azure Signaler. Why I compare these? Because if you have already a legacy application which use Signaler, you can see it's just in a glance to move it to the Azure Signaler. It's just changing a few commands, that's it. And then the hub class, which is one of the most important part of your application. So you just instantiate a class from the hub class, which is a class from Signaler, and then you write whatever functions you want the clients to make a call. So from now on, the clients can make a call to my broadcast messages. So they can send the message and the name, and then the hub class will make a call to all clients and send a message to all of them. So basically, server is going to invoke this method from all connected clients, which is interesting. Then your front-end application. I use Vue.js, you can use anything. Then after you set up your front-end application, you just easily install the ASP.NET Signaler, which is the library for client side. So interesting part, you have 2 libraries. And then you import the library. Same for client side, you need to set up your hub system. So in the server, you already set it up. In the client, you do the same. So you connect to your ASP.NET Core application initially to start the connection. And then you can make a call to your server methods. And you remember this method, right? That one. So you basically make a call to the server. And then the server will make a call again to the client. So it's kind of back and forth. So the client method, which is this one, will be invoked. That's all the process. That's done. I already showed you that the interesting part is your Vue.js or your client-side application make a call to the ASP.NET, but they will redirect it to the Azure, which you already saw that. The benefits obviously we talked about the benefits. You don't need to set up the Redis cache, you don't need to set up the sticky sessions. Azure Signaler, as you saw, it's easy to set up, just adding a new resource, that's it, getting the key. And your scale out will be happening with less cost because obviously, when you have the web server, you don't have only your Signaler on your web server, right? You have a lot of other applications. But since Signaler use the TCP connections, so the scale out will be much quicker than the normal applications. It means that your web server will scale out without really need to do that. Lots of applications and other applications need to scale out without really a proper reason. But with Azure Signaler, it's not like that. And then for me, it's a really amazing part that you have the support for serverless applications. So if you don't want to have the ASP.NET Core, all good. Back of your card is the reference to my weblog. So I have all the codes, all the details, the slides, everything for you. So you can go and have a look and all the other references I use. And the other part, I'm sure you love to get the prize and I love to get the feedback. So it's a win-to-win. And you can please go and give me feedback so I can improve my presentation next time. And that's it. If you have any question, please feel free to ask. I know that I'm standing between you and your lunch, but I'm around. If you want to ask questions, do it. Otherwise, I'm around and we can discuss. Sure. Yes. No, I haven't provided any example. Yes. I didn't go through the serverless part. It was a little bit taking time from me, so I couldn't prepare that examples. But when you create the Azure Signaler service, one of the options is asking the Azure Signaler service that I want to connect to the serverless. The last option that probably I didn't show you. So when you select the serverless, then it knows that how to set up the communication, and then you need to get the key and then introduce it to the serverless application. There are a lot of good examples. This is why I didn't bother to do that. So if you go to my weblog, there are a few links to Anthony, I think, weblog. So he provided very good examples of serverless, and then you just need to grab the branch and use it. It's so easy. So yeah.
Why I'm asking if you're working on another serverless.
Oh yeah, yeah. Many companies are on serverless, so this is really interesting to see how it would work. Yeah.
On that proxy, is this limited connection?
Yes.
So is there like some mechanism to put the queue or something on the connection become available? What kind of have an exception?
Having a queue to line up the connections, you mean?
Let's say 3 ones,
Yeah.
right? So let's say when you first connected, I obviously won't be able to connect. Right? They have an exception.
Oh, you will get the, you are running out of the connection, something, yeah. You will get,
Implement myself or connected after.
yes, that's right, yeah, yeah.
Is there a Signaler client library for Android?
For which one, sorry?
For Android phone?
For Android, I'm sure there are a few for Java and the other stuff. I'm not sure for Android. Yeah, but it's more JavaScript, I think. Yeah, friendly library. Yeah, but I'm not 100% sure. I can check.
I think there is one library.
Should be, should be. I would like to give this to you two. Thank you for asking questions and thank you for participating in the demo. Really appreciate it. So if there is no more question, I just leave you to have your lunch and enjoy the rest of the day. Thank you.
Yeah.
Sure.
For the local development, do you usually use like normal single R for local dev and
Yeah,
Azure
same.
for
Yeah. Just 2 moments, folks. We're just doing a quick setup still for lunch. There is more stuff to come out. There's a choice of vegetarian, ham and turkey Subway sandwiches.
Cool. All right. Thanks, everyone. I hope you had a good lunch and you're not feeling sleepy at all. I'm here to talk about the Azure Cognitive Services, as Simon mentioned. And my name is Somi, by the way. And I'm going to show you how to build a descriptive assistant relying on cognitive services. But before we start, I'm going to tell you a little bit about myself. I've been in software development for more than 15 years. I have a .NET development background, and I'm a Scrum Master, and at the moment, I'm a development consultant at Cloud Solution. What we're going to do today, we're going to see who can do this, and then we're going to go through the cognitive services, and mainly I want to talk about the one that I used in my demo. I'm not going to cover all of them in more details because each one requires its own session to go through it. And then I'm going to show you the demo, and then we're going to wrap it up by a QA session. So anyone can do this. I'm going to tell you a little bit about myself. Being consultancy gave me this opportunity to wear different hats based on my career interest. So in my previous engagement, I was a Scrum Master on a client for 20 months. So I was away from coding for that period of time. And as a developer, you can imagine what that can do to you as a developer. So it was really hard for me to get back on coding because I wasn't feeling confident enough to get back on it, although my background was .NET. But because I was away, and you know in IT how it works, every day new stuff comes in, so you have to keep yourself up to date every day to be able to be in the market. So when I was given this opportunity to come here and talk about cognitive services, I thought, yeah, this is a challenge, but it kind of put me under pressure to get back in coding because I miss it so much. So that 20 months was really, I was involved with the tech team, so I could see what they do every day, and I was missing out on those. So when I finished my engagement, I asked my boss, I want to do coding. I want to get back on coding, so I need to refresh my memory. And being here today and working on the cognitive services gave me that opportunity to do that. And I worked with AWS, but I haven't done any real project with Azure. So I had minimal knowledge on Azure, specifically on cognitive services. But I had an idea, and I thought, in high level, I knew what they do. But I had an idea, and I said, let's see if I can build something like a prototype using cognitive services. So what are the cognitive services? Cognitive services is a collection of artificial intelligence API. What it means that regardless of your, these are a bunch of REST APIs. So it's already built-in feature and functionalities that you can use. So regardless of your skill level, you can just hook into these APIs and you can start working with them. And even regardless of the platform that you work with, if it's in the iOS, or if it's Android, or if it's Windows, if it's a web page, you have the option to just connect to these REST APIs and start using the functionalities. So everything is kind of built in. So that made my life much easier because I didn't know how they work to begin with. But having those RESTful APIs gave me the opportunity to just look through them and see what function I can use, what function I can rely on, and what can serve to my purpose. That's how I started building this prototype. Why using those APIs? Because they're easy to use. It was really easy and straightforward for me to use, and it was flexible because you can hook it to any platform that you're working. So you're not dependent on any platform, any language programming that you use. So it's a kind of platform and language agnostic that you can rely on. And it's been tested. So there are lots of resources available for you to jump in and start learning about it. That's what I did. I had no idea how they work. So I just went to Microsoft, opened up the MSDN, and started reading through them. And I started reading about each of those cognitive services to understand how they work. And these community, these resources helped me a lot. Out of the existing cognitive services, I'm just gonna focus on the one that I use. There are other cognitive services in Azure, but I'm gonna talk about the vision, speech, and language, and these are the ones that I used in my demo. The vision API, what it does is actually try to analyze the image or a video for you. So it tries to identify the objects and the content within that image. Even it tries to read out the text if they're using the OCR within that image. So it also can identify face and emotion out of those face. The speech API helps you to to convert text to audio and the other way around. So it was really cool feature that you can do that. So you can kind of read out text by clicking on a button. And the language API, the key feature that I used was a translator one. So if you're reading a text and you're not familiar with let's say, English, you can use this feature to translate English to any other languages. There are a bunch of supported languages in Microsoft that you can use, so it can support reading 9 languages and 60 languages as a text. So 9 languages if you speak, and 60 plus languages as a text, so it can convert and read out those texts for you. And the speech API is based on the Bing search. So even the product that we currently use, the product that is out there, are relying on the cognitive services. Okay, let's get into a little bit more details. The Vision API has a couple of features. So as I mentioned, using the computer vision API, you can distinguish the objects within the image. So you can find out the content what image has. So you can see if there's a bicycle, if there's a sky, if there's a tower. I'm going to show you some of the example later on. It has face recognition, as I mentioned, so you can tag faces. And also it has content moderator, which I really liked. Some of these features in preview at the moment, but what it does, it helps you to filter out any inappropriate or inappropriate data from your image or a video that you have. So you can filter out what you're going to convey to your customer. The custom vision, it helps you to train your API. So you can give your own data set, and you can train your API to work based on your need. So this is really cool, and this requires another huge session to go through. So what it means that you can start providing data to custom vision, and you can train your API to read and detect and recognize and identify different objects. So as it matures, the accuracy and the confidence level goes higher. And also, the emotion API is not there, but it can detect the emotion out of the face. If people are laughing, if they are sad, if they are crying, it can detect those emotions. And it also can kind of roughly guesstimate the age of the faces that it can detect. The speech API, as I mentioned, it provides a state of it is relying on the Bing search API, and it has a speaker recognition. It helps you to convert the text to audio. It also can cancel the background noise because when you're talking, you have lots of background noises. So it will identify the main speakers and try to listen and hear what it has to say. And you have the option to convert that audio to text and the other way around. Yep. And lastly, the language API. As I mentioned earlier, it helps you, it can detect what language has been written, what language has been spoken. So you have the option to recognize the language first, and also you have the option to translate those languages to other languages in your need. Any questions so far? Cool. Am I going too fast? No? Cool. All right. Out of those services or the feature that it has, I use these 4 in my demo. So I'm using computer vision to just analyze an image or grab any text that it might have. I'm using the speech API to convert that text to speech and the other way around. And also I'm using the translator API or language API to translate that text that is been written on an image. Okay, so the API response is a JSON file. And what it has, based on the header that you can define, what it gives you is a description, tags, and as part of that, as you can see, it tells you what object it can detect or it could detect from that image. So it has the overall confidence level, which you can see 83% of the whole overall image, and it could see this one, people waiting at the train station. So this is out of the box and built-in feature in custom vision API. So without doing any additional code or without training my API, it could give me that level of confidence by identifying the object over the image. And also, it gives us tags. So each item that it recognizes, it gives you the confidence level of each item. And you can see this is 99%. This is, I don't know what pooling means. Pooling is 43%. So this was really helpful. And you can use this tagging to index it. And you can use this tagging to do searching. And you can use this tagging to train your custom vision API and use it in more powerful way later on. There are a bunch of other examples. So as you can see, it actually could identify. So it's a black and white photo of a city. It could identify the color as well. So it can tell you what color it has, the photo has. More samples. This is the kind of face recognition part of it. So it could see the people. So if you define a specific type in your headers, and there are features that you can use, you can detect the emotion out of those faces. And the last one is a kind of a blurry one. So it wasn't sure that this photo has a cloud. So as you can see, the confidence level is quite low. But you can train your API using the custom vision API to start detecting different type of clouds in your different type of images, and it will get mature as it goes. So you can imagine what they can do. So there are people with low vision, or they need help to, or visually impaired people. So this feature can really help them. And that's what gave me an idea to build this prototype that I'm going to show you later on. So in a nutshell, the computer vision analyzes the image. It uses OCR to detect any text, and it also recognizes celebrities. So if you want to train your custom API to recognize you as a celebrity, you have the option to do so. And as I mentioned earlier, you can detect the age and even gender of the people that it has. And as you can see, the response is quite straightforward, so you can use it in your code. And everything is built in. You don't need to do anything. You just need to call the API that gives you this much information, and you can build lots of cool app with it. Using OCR, it has the option to read the handwritten as well as a printed one. So you just need to, if you're giving a different type of images, you just need to tell it, okay, it may be handwritten, it may be a printed one, so you can detect both options. Same goes for speech API. So I'm going to play a little bit of audio for you, and you can define what the difference is. So I'm not sure if you heard it all, but this is the out-of-the-box speech API. So it's without any training. So this is the built-in power provided with the Microsoft data. So, and you can see the difference. The actual audio was this one. So this is more accurate than this one. But this is a custom speech recognition, which you can train it. So what it did, it actually canceled all the background noises, and it helps to recognize the main speaker and the intent of the speakers. All right. Talking about this stuff, I just explained about Vision API, I explained about a speech API, and I explained about a language API. So now I'm going to jump into demo. The idea that I had was, as I mentioned, there are people with maybe low vision, and maybe I forgot to take my glasses to the shop, so I might have a problem. Or there are people that they cannot read the text. So the idea was to help those people, or maybe solve a problem that they might have in your daily work. So that was the idea that I had, and I said let's rely on existing cognitive services and the powerful engine which is already built in, and see if I can make a prototype out of it to actually help people. So imagine that I forgot my glasses to go to shop, and I'm allergic to something. I really need to read the ingredient of a content when I go shopping. So either I have to ask somebody else, or I need to get a magnifier, or somehow be able to read the ingredient. So it would be really good if I can just use my phone, maybe take a photo, enlarge it, and read it. Or if I don't know how to speak English, I just take a photo, post it somewhere, and it translated for me. So that was the whole idea that got me to building this prototype. I realized, so giving you my background, I had little knowledge of cognitive services. I just, like a couple months ago, I just started learning about cognitive services. I started learning about computer vision, speech, and the language. And this is how I use them. So I just went through the documentation, see which functionality that I can use, and then I built those. It was very time-saving because I didn't need to build the actual underlying engine. It was already built in. For me, it was just a matter of time to connect to those APIs and reading and using those APIs. So this is basically a nutshell of the app that I'm going to show you a demo of. I'm going to tell you what I did, and then I'm going to show you a demo out of that. So I've got an Azure web application. It's a simple one-page app, and what it does, I take a photo or upload a photo from my phone, and then I upload those photos to Azure Blob Storage. Then I use Computer Vision API to see if there is any text written on that image. I grab that text, I pass it to Speech API to convert that text for me to audio. And then I can play that audio. So what I did was I saved that audio file back into Blob Storage, and I play that audio for the customer. And in the end, I use Language API to translate it maybe to Chinese or Spanish or the other supported language that you have. So I've got a bunch of stuff here. I'll see if I can give you a quick demo. But bear in mind this is not the final product, so it doesn't have the fancy look of the UI. So to all our expert and front-end developer, I apologize in advance. All right. Coolio, please. Okay, so this is, as I mentioned, this is just a web app. So I didn't create a like iOS app or Android app because I took the easy path. I just wanted to get the prototype working without doing anything fancy with it. So this is the URL that I'm going to share with you later, so you can go ahead and use this URL. All right. So as you can see, it's an ugly web page. You have the option to take a photo or upload a video from your library. So let's see if we can read this. I just say, read it. Finger crossed. Okay, as you can see, it kind of read out the text. So I guess it's pretty accurate. I didn't put the confidence level, but let's see if it got it right. So as you can see, it has this funky voice, but you can use the speech API to make it more humanized. So you can define what kind of person it's going to be. You want it like a female person or a male person, or even you can use your own voice if you want to train your speech API to do that. And as you can see, I didn't get time to kind of do the translation bit, but what I had was, what I had was I just translate this text to Chinese, I guess, and the Spanish one. But as I mentioned, you have the option to translate to like more than 60 other languages. And then what you can do, the next step can be, rather than reading out the English one, you can read out the Chinese one, or you can read out the Spanish one. So you just need to define your headers. I didn't do much coding to build this one. It was already out of the box and built in for me to use. Any question on them? Feel free to grab that link, try it for yourself. Although I'm using the free version, so I'm not paying, and I'm not sure what is the threshold is. So you might be able to break it down the track. Yes?
Is it possible somehow to train to extract some specific information? For instance, in this case, to find the allergy, what is allergy? So just not just by kind of saying, I saw that from your first picture, you have like a tag, so I can just find the confidence way of this stuff. But in this case, it's just a tag and a content. Is it like possible?
You can train your API, so you can give it like list of the keywords to look for. So you can give it a subset of, as I mentioned in the,
Yeah, it's true. It's like in this case, I'm not actually talking about like a keyword. I'm actually talking about the content, what comes after that. So like, can you logically understand this is actually part of the allergy kind of stuff. And this one is become next text. You know, like to just separate the logic.
You have the options to kind of identify the headers and also the content of the text. I didn't get to that part, so I just asked the API to read out for me regardless. But you can formalize it. You can just define if it's a header or if it's a content, if it's a number, read it like this or like that. So you have that option. And with the train, with the custom speech API and custom vision API, you have that option to do that. And as I mentioned earlier, you can even use tagging. You can index it to search for specific keywords for you. So if you're looking for like allergic one, just go ahead and do that. So you can pick the keywords rather than giving the whole text to the customer. You can just grab the ones. And also, like any other things, you can append your own text. So you can say, okay, in this page, I see a box of like chips, and it has this and that. All right, let's get back to presentation. I'm glad that it worked. How I'm doing with the timing? I've got 20 more minutes. Please. Okay, where is my... Okay, just recapping on what I just showed you, you could now maybe understand a little bit more. So it was a simple web page. It uses these three APIs, so 3 different calls to give us those results. And there are lots of other functions and the features that you can use out of those features. And I relied on the Azure Cognitive Services to do so. I prepared a little video in case this live demo didn't work, so I'm not going to show you that. I'm just going to move on. So I'm going to show you the code and how I build this app, but I put the code in the GitHub that you can use, and also the link that you can try it out for yourself. All right, let's jump into the actual code. All right, so it's just an MVC app that I have one controller and maybe 2 services. So in the controller, the only thing that I needed was to grab the photo and maybe stream it and upload it. So this is how I've done it. I just grab the photo. This is the post call. I just grab the photo. I use the storage services to upload it to the blob. So if I go to the storage services, this is how I've done it. So in order to set up the Azure, it's small. Okay, it's better. All right, so in order to use these services, you need to set them up in your portal. So you need to set the Vision API, the Vision resource, and also you need to set the speech as well to be able to use those. So in the previous demo, Nelly showed you how to create a resource in Azure API. You just need to grab the key, and you just need to create a connection here to be able to use those APIs. I just put all those information down here. So the connection is string, the URI base that you need to use, and the subscription key that you need to use for each services. So for Vision, they have their own set of keys that you need to use. So a speech API has its own, Vision has its own. So whatever you use in Azure, you need to make sure that you're connecting to the right resources in Azure. Okay, back to storage services. Let's see. So what I actually did, I just created a connection to the blob storage. I have one blob already ready for me to use. I created one in Azure that I could use. You have the option to create your own as well. Or you have the option to put every single file to separate blob storage. And what I did was in the end to just upload that photo up. And you can see it's a matter of passing the stream or the byte array of those files. And then I use the analyze method to read out the text. As you can see, there are very few line of code, so I didn't do anything. Everything was real. Everything was ready for me to use. It was just a matter of connecting and hooking up to those services. So as I mentioned earlier, you have the option to use the different type of text, either it's printed or handwritten or both. So you have the option to tell your API what are you after. And I just define the type, and I just prepare the headers. From the context of that image, I need the, tags, description, the type of the image, and the text. So I just add that into my header, and I just pass it to the API to read it out. I got the result back, and then I just pass it to my model. The code is available on GitHub, so you can go and read through it and also use it if you want. The other option, then what I did was to just call so I grabbed the text using the Vision API. Then I have a little method here to go ahead. So this may be helpful. So so what I want to do now, I want to read the text. So I want to use the speech API. So you have the option to create your XML document. So you can define what sort of voice you want to put that in. If you want to be a male or female, what kind of a voice, if you want to be in English or you want it to be in any other languages. So once you translate your text to some other languages, you may need to change this to be able to read those different languages using your API. And then, again, it was a matter of just creating a request and passing it through, get the response back, and you can stream the data from there. The next part that I used was to actually translate the API. So what I did, I went to Azure portal, I just created a language API, language resource, and you grab the subscription key, I put the URI base, I just called the API to translate that for me. So everything basically was ready for me to use. I'm just going to show you where I defined, where is it? I put it somewhere, okay. Okay, as you can see, I have this. So in my header, I'm defining what languages I want to translate to. So this is the abbreviation for Chinese, and this is the Spanish one. And you have the option to add more language to it. So I just passed those parameters to my API, and that did the magic for me. And I guess that was basically it. I can give you another live demo, and then we can. All right. I still have 15 minutes to go. Let's see if we can use, see this one? This is pretty small, so it's very hard for some people to read. And also this one is blurry, so I can try maybe, I'll go with this one. So as you can see, it gives us this information. So it gives us the ingredient, and also it's going to read it for you. I'm sure you don't want to hear it, but that's what it can do for you. I'm not seeing the details. And the details is down here. So you can see it translate the options. I'm not sure how accurate it is because I didn't capture the confidence level, but it did the job. All right, let's get back to the presentation. Any question?
So you said you started from scratch, right?
Yes.
So how long did it take you to put it together? And second question is, if you want to do it from scratch, what is the best way to put it together?
So the way that I did it, because as I said, I had little knowledge on how Azure cognitive services work. So what I did was I jumped on Microsoft website, I typed in cognitive services. There are lots of information online that you can use in Microsoft website. So it even has the sample code that you can use. So it gives you, the first thing that I did, I created a console app. Copying and pasting those code and just going through them and see how they work. And it actually worked. And then I tried to pick the functionality that I want to use for my app. And everything was available. There are lots of sample codes in GitHubs. There are lots of in Stack Overflow. And also MSDN helped me a lot to be able to build that. It didn't take me that much time. It was a challenge because I wasn't feeling confident because I haven't done anything with Azure before. And it was away from the coding. So it was a big challenge for me, but I try to use that as an opportunity. The information online is pretty straightforward. So the more that you use it, the more you understand it. So even I had some issues trying to use the computer vision because I was using different drawing method. But the website has enough information for you to understand which method is going to work for you. And these are all asynchronous calls, so you just need to be a little bit careful about how you're calling those methods because you don't want to get into the deadlocked loop, and you want to make sure that you trigger the other method once you finish the previous one because you may need the result or response out of that to put it in as an entry point. So you could imagine what I could do. For me, it was impressive because I haven't done much with coding, as I said. And it was really easy because I thought, yeah, I can solve the problem. And imagine what people with more experience can do. And I'm going to show you a video of Microsoft. So a couple of years ago, Microsoft created an app relying on these existing services and actually helped to solve a problem of a customer. So as you can see, this video is just a proof that what we can do and what sort of powerful app that you can build relying on the cognitive services and actually help to solve a problem of people. If you want to get it started, just jump into azure.com cognitive services, and also you can rely on the Microsoft documentation to start building your own cool app. Any question? Yes, please. Sorry? I use the free version. So I guess maybe Simon can help out with the pricing. I didn't look in the pricing, but I'm using the free version. So with the free version, you can actually create and build your own prototype to see if an idea actually works. And then if you want to extend it, and if you want to get more use more feature out of the cognitive services, here's the guy that they can talk about the pricing. Okay, thank you.
It's consumption-based, as most cloud stuff would be. As Somi said, there's a free tier for all the cognitive services for you to try out. And then most of the services have a single price consumption tier, which is per number of calls on the API you're making. So it varies depending on what service you're using. If you're building a big enough application that's going to have millions of concurrent requests, generally you want to come and speak to us about those scenarios. Questions for Somi, not for me.
I'm going to pass it to Simon, just ask. Yes, please.
I'm just wondering, like, this computer vision, if there's anything exists for like 3D vision, like for 3D point cloud recognition, like not just point of cloud or STL files or something like that?
That I'm not sure. There might be.
Not in this scenario.
Are there something planned?
But seeing AI, it actually could identify the image right away. It was a real time, but it actually take a photo, so it's not 3D. So yeah, I'm not.
Have a look at what they call spatial anchors. It's a service that spatial anchors. So it's part of the augmented reality work that we're doing to do with HoloLens. Which services is correct.
Thank you. Do you have any use case for enterprises using this cognitive service for getting some beautiful data and information?
Sorry, I didn't get that.
Are we using this anywhere in enterprise currently, or do we have any use case for it, apart from doing experimental things and doing for your own ideas? There's any industry base getting somewhere?
I don't have a real case, but I'm sure it's been used in lots of products because the feature that it gives us, it really can empower your apps. So if you have the audio in your app, you may want to use it. So it's based on it's a kind of feature based that you can rely on. It's not that if you want to use the cognitive services, you have to use them all together. You can just pick the one that you need for your app. And I'm sure that it's been used on current app that we use. The speech API that we use, it's based on the Bing search API and speech API, so it's already out there.
Uber uses a driver app, uses the face API to do facial recognition for Uber drivers. That's probably the best known one. There will be other case studies though.
And maybe the plate recognition in some of the petrol stations. Yes.
Yeah. So if I'm using this cognitive services, right? So there's a pre-built model behind the scenes, so you upload your data and you get it right? So is this data that we are putting is being used to refine models, or no?
Yeah. The data that you provide to these services is your data, and Microsoft doesn't retain it or use it for training purposes.
So you just got it right away.
Correct.
So there's no problem using these when you're right.
It's a question that's come up before, and I checked in the advice. So some services are quite explicit about it, but the general principle is that we don't retain or use customer data for all the improvement of these models. It's basically you upload it, it stays in your cognitive services container, and doesn't for our service.
So when these services, it's region-based or
it's like all services, it's region-based. They're available here in Australia recently. No, there's no question.
So can this model be trained also? Like can we train it using our images?
Yes, you can use a custom vision API and a custom speech API. As I mentioned, you can provide your own set of data and you can start training your API based on the tags, based on the information that the key information that you want to build up. But that requires another set of configuration.
Just a question about translation.
Yes.
Does it support speech translation as well?
Yes, you can do that. It can translate 9 audio, but it can translate 60 above languages, text,
Right. So
at the moment. So.
simultaneously or?
You can get the partial translation. You have the option. So while they're talking, you can get the translation. So there was a sample that when the person was talking, it was writing the text while the speaker is talking. So it has the partial translation. Almost, yes. I believe it could identify the main speaker and it could identify the intent of the speakers. But if they're talking at the same time, I'm not sure, it might. If it's a dialogue, it will, yes. Yes. Speaker recognition is part of the feature that it has. Any other questions?
Apart from this API, do you have any other API more intelligent, such as like data analytic parts, be able to analyze the data just given the data required? So give you an example. So given like all the customer data to find out, for instance, to recognize which region they come from, and so you can summarize using that API service as such.
Well, we have plenty of data analytics style services, so there's a combination of services that you could use. Probably the best one you would have overall data would be Power BI.
Power BI, and this would be one to use.
Yeah, depending on what you're wanting to do. If you're wanting to do that kind of dashboarding, querying style experience at Power BI, it also has data analytics, data warehousing, and a lot of other kind of large scale batch style processing solutions in Azure as well.
Yeah, so the reason why I bring up this question is I saw these cognitive services providing a predictive model based on the data you have. So if you have so many people, like for these people coming here, if all people come on Sydney, you probably can conclude that all people is actually from Sydney by local people, 99% from Sydney. So it's a kind of like predictive model. That's what I'm looking for.
Sure. So there are ways that you can bolt these services into say data analytics pipelines if you want to. At the end of the day, they're just simple REST APIs that you push the data through.
Yeah.
So you can certainly use it in that way if you wanted to. If these models don't work the way you want, you can use something like machine learning studio.
So fully integrated with those two.
I have a such question. Let's see. Is it with a single data source that you can feed in, or you can recognize the pattern within the different data set and they can go across different data set or the pattern?
I think it's probably well outside of the cognitive services of that. Probably more into data analytics space. Cool. Any more questions for Sonia?
Sorry? Any image? I haven't encountered any while I was working on this app. So I try to provide different type of images or even the video. I didn't encounter any, so I'm not sure if there is any. Cool.
Who's the best question?
There were a couple. Can we get more of these? So I'm going to give one to you. Thanks for your questions. You already have? Okay, cool. One for you. There you go.
While Somi's doing that, how about a big a big round of applause for Somi?
Thank you. Thanks, Simon.
All right, so I think we have 15 minutes until the next session kicks off. Somi's here if you want to come and ask her some questions. We'll have another dev track item in here, so Suhas is going to come and talk to us about testing in Azure. In the other space, Scott's going to be talking about digital twins for managing your IoT solutions. So that's in just under 15 minutes.
Good afternoon, everyone. So I'll give you guys a quick minute so you can go and grab your coffee. I don't know if there's a big line there. No? Okay. And those of you in the room, I would encourage you to come in front, so, if you feel. All right, so today I'm going to be talking about a subject that you would rarely hear, right? I mean, a lot of us kind of take it for granted. Testing, hey, we know it, we do it. What's the value, right? I mean, you don't really see a lot of sessions, a lot of discussions on testing. So a little bit about myself. My name is Suhas Rao. I work for Microsoft. I've been with Microsoft for about 9 years. I actually started at Microsoft as a developer. Played various roles in Microsoft. I was a consultant on the field. I was a pre-sales architect. Now I play the role of a cloud solution architect, again in the app dev space. The reason I'm limping is because a couple of months back I injured my knee, so I might have to sit down, so I was able to grab the only high chair that we have got, the one used by our security guys. So don't mind if I sit in between. That's my Twitter handle, my LinkedIn. So there were a couple of novels that I was actually reading in last few months that inspired me to even talk about this subject. These are the books, those of you who have access. So these are kind of fictional, but it has a lot of knowledge around technology, around DevOps, around testing, which I kind of found invaluable, right? This is called the Phoenix Project and the Kitty Hawk Venture. So really great books. That's what inspired me to talk about this topic today. All right, let's start with a quick question here. Whose responsibility is software testing? How many of you think, raise your hands, how many of you think it's the responsibility of developers? 1, 2, 3, 4, okay, that's good. How many of you think it's the responsibility of business analysts, product owners, stakeholders? Okay. How many of you think it's the responsibility of quality analysts, test engineers? And how many of you think it's the responsibility of end users? Yay. Can I give this award away? Cool, good. All right. So we'll hold on to that question. I'll try to answer. More than that, I think the session is going to answer. So today, the pace of business is changing, right? So again, this is what was told by Bronwyn Clare from Telstra Corporation. A few years back, right? So we used to have, these huge projects that would run for 18 months, 24 months, 2 years, 3 years, right? How many of you are still working on such projects? Anyone? Thank goodness. Oh, okay. All right, so things are drastically changing. The business has become cutthroat. For you to maintain that competitive edge, right? Businesses have to invent, innovate, and be able to deliver their products as soon as possible to the market, right? There was actually an interesting thing that happened a few years ago. So a few years ago, I was in States. There was actually a travel site that was quite popular in East US. So what happened is just before the holiday season, they had a little bit of a glitch and their site went down. And now whenever someone was searching for this a travel site, right, they had their competitors who kind of started showing their ad. And their ad basically read, hey, lost your vacation? We found it, it's over here. And it would redirect the users to their site, right? So that's how competitive the business is. And how quickly, knowing that, okay, this site is down, these guys were able to modify, put this ad, and basically redirect the users to their site, right? So the business is pretty cutthroat. Another very interesting conversation, very interesting topic that you may have heard is this, right? This actually comes from our CEO, Satya. Every company is a software company, right? So every company today talks about digital. There are some interesting statistics. An average enterprise today has about 464 custom applications. And then in the next 12 months, a study shows that there are going to be 37 new applications that are going to be added, right? So digital is the way forward for all businesses. It's not only for IT, right? It's not only for technology companies. So for you to be innovate, for you to be able to stand out from your competitors, you need to adopt some or the other form of digital. All right, let's play a game, right? Let's take a coin and let's toss it. So how many possibilities are there? What are the outcomes? How many arrangements can we do if I toss this coin? It can be either heads or tails, right? Basically, 2. So what happens if I have 2 coins? How many possibilities? It can be heads and heads. It can be heads and tails. It can be tails and heads. Or it can be tail and tail, right? So we have 4 possibilities. Is that correct? All right, we'll take it further. How many possibilities or how many arrangements can I have if I have 3 coins? 8. Brilliant. Okay. Now the next question. If I want to have 1,000 arrangements, how many coins do I need? Anyone? 10. Perfect, yeah. So as you can see, right, all we needed was just 10 coins and we had 1,000 different combinations, 1,000 different arrangements. It's in fact, for 10 coins, I think you'll end up having 1024, right? And software is something very similar. The complexity of software grows very similar to how by adding a coin, the complexity increases, the arrangements increases, the possibility increases, right? There's a very short example, right? Suppose you are creating a settings page and each of these settings have 2 values, let's say on or off, right? With 5 settings, that's 32 possible configurations. Now, if you were to add that one additional configuration, right, the 6th setting, you'll end up having 64 different combinations. Now you'll have to start testing this across all these combinations, right? And now another thing, right? Applications. The applications of today are not running in isolation anymore. So the application that you build has dependencies. It talks to another application. It talks to various forms of devices, right? There is IoT in picture. So how can you actually determine the impact of your change? Are you ensuring that whatever change that you're making will not have or it will not break anything on one of the dependent systems? You're probably, let's say, you're changing the data type of one of the variables that you have in your program code. There is another application that is talking to your application. Are they handling it? How are you going to communicate this change to them, right? So the application architectures are becoming increasingly more distributed, more complex. People are embracing cloud. People are embracing APIs, microservices. Basically, we are ending up creating a virtually endless combinations of different protocols and technologies within one single business transaction, right? Has anyone seen this spectacular fireworks? Is this fireworks? Anyone knows what this image is from? Anyone? Cyclone, okay. Yeah, so it is basically this rocket that was launched, I think in 1996. It's called Ariane 5 from European Space Agency. Just a few seconds after the rocket launch, that is what happened, spectacular fireworks. And does anybody want to take a guess what was the cause of this issue? Software. Brilliant. How easy could it have been? Okay, so let's go one step into the detail. It's software, but what happened in the software? Any guesses? Anybody who has read? It's probably hard to guess. Mm-hmm. Divide by 0, okay. Close? Okay, pretty close. So it was basically float to int conversion. This is actually published in 1996. And the amount that they lost was $370 million for an integer overflow. Massive, right? So in more recent times, this happened in 2012. Again, any of you, this is the trading firm, Knight Capital. It cost them $440 million. Why? That's because someone forgot to unplug remove a block of code that was running on one of their 8 servers. Seriously? More recent, AWS, right? So what was the cause of this issue? So basically, S3 went down. This was in 2017. Sites like Expedia, Quora, right? They were all down. The reason? There was a typo. Seriously? It should have been caught. How did it make that far into the production? Yeah? So some of these stories, I don't know how many of you follow this white paper. These guys actually publish this every year. It's called the Software Fail Watch. So these are their latest numbers. So what these guys do is basically they go ahead, they look at all the publications that are, again, only in English. They look at all these losses, then they kind of aggregate, and then they publish in this report. Just from last year, the loss is about $1.7 trillion. And the numbers, this is based on 606 recorded software failures that had impacted half of world's population, that is 3.7 billion people. So we know the number, it's 1.7 trillion in assets, and by 314 companies. And again, this is what was, yes, question? Yeah, I mean, so probably it's best, you can look at this report and see, yeah, which company, really was the leading the herd, right? So. There you go. Do we have more water bottles? Otherwise, people will stop asking questions. So this basically kind of reminds us of the role software plays in our daily lives. This is how embedded software has become today. And if we are not doing a good job, if we are not doing a damn good job of testing before we actually put the software out there in the wild, this is what's going to happen. So how much more do we want to lose, or how much more can we afford to lose? Yeah? So the question is, are we getting better at testing? Right? So this is, again, a comic, right? It basically kind of says, a manual tester, when you start the project, when, again, the application code is small, there's a lot of adrenaline, and he is happy finding bugs at that point of time. Then somewhere in the middle, basically there's a boredom low, right? I mean, so he's been doing the same thing over and over. So as long as he finds one bug, he's happy. He just goes reporting that. And then just before the release date, he finds a bug, and then he's like frustrated. That basically is his blood pressure rising, right? The stress spike. But the reality is testing is actually changing, right? So a few years back, right? I mean, going back, when we were having that waterfall model, testing was almost considered as an event, right? So you do all your development, then you finally have the test team come and basically test your application, and then they say, hey, this is good to go or not go, right? But now this is being shifted leftwards. And it's being shifted much closer to the beginning of the software development cycle, right? And in fact, that wall that basically separated developers and QA, that's being broken down as well. So there was actually a major event that happened within Microsoft, right? So in 2014, prior to 2014, we had two different roles. We had SDE and we had SDET, Software Development Engineer and Software Development Engineer for Test, right? So basically the QA folks. So what we decided was to combine these two roles. into one role of a software engineer, and the software engineer was actually responsible for writing the product code, he was responsible for writing the test code, and he was also responsible for writing the tools code. So the basic idea is we must stop thinking testing as an event, right? So it is something that has to be a continuous process that happens through our SDLC, continuously throughout our SDLC. So while the testing is changing, right, there are still some inefficiencies, there are still some shortcomings. These are again some numbers. 63% of software development delays today occur in the test or QA practices across life cycle, of which 56% of time is basically looking for those critical dependencies. 50% of time is spent looking for test data. Next point is quite interesting. 64% of the defects occur in the requirements phase. Would you believe that? But that's true, yeah? And 70% of testing, even today, is manual, right? So if we were to prevent those disasters, like what happened to Ariane 5, or what happened to AWS, or what happened to the trading firm, right? So we need to start getting better collectively. And that's where all of us have a role to play in what's called as continuous testing, yeah? So what exactly is continuous testing? What is the definition of continuous testing? Just a minute, sorry. So continuous testing is basically the practice of testing across every single activity in SDLC, so you can uncover and fix those unexpected behaviors. And also establish those quality gates, right? As we move through that pipeline, we need to ensure that the quality of our code really gets better, right? So how many of you here are developers? That's good. And how many of you have written code without any bugs? Good try, right? So we all know and understand that it's inevitable, right? I mean, but what we can do is have ample amount of testing. Again, it need not be manual, and we have these tests throughout the entire SDLC so that they're caught early and they're handled, right? So there are various ways, automated testing, automated unit testing, integration testing, coded UI, load tests. Again, these are all common in continuous testing. Also, another characteristic of continuous testing is the depth of testing often progresses as the environment gets closer to production. However, right, in practice, continuous testing is one of the most difficult part of setting up your CD pipeline. All right, one other common question that actually people ask me when I tell them about continuous testing is, they say, hey, we are doing automated testing. Isn't that same as continuous testing, right? And that's where there is a key differentiator, right? So with testing, the question we asked was, are we done testing? But the actual question that we should be asking is, does this release candidate have an acceptable level of business risk, right? So for us to really understand the difference, right, between test automation, which is basically a small subset, right? I mean, of course, test automation is important, but it's only a small, it has its place in the larger scheme of things, which is basically the continuous testing. So think of this as a 3D cube, right? We have risk, we have breadth, and time, right? So this is what we call as continuous testing. So if we don't have test cases that measure the business risk, how do you identify? So what happened with traditional test is, you were basically looking at user stories, and then you say, hey, this test basically tests this particular user story, and as long as it's meeting this criteria, I'm going to pass this, and this software is going to make it into production. But you are not really looking at the bigger picture, which is, what is the potential impact this particular bug could have on your business, right? So you need to start judging that risk. Also, the breadth of testing in itself is increasing, right? Today we have support for many platforms, right, from iOS devices, Android, different platforms, different form factors, landscape, portrait, right? I mean, you need to start supporting your software for different form factors, different platforms, right? And also, you need to ensure that the end user experience is still not impacted. It doesn't matter what type of device he uses, what type of connectivity he has, from where in the world he's able to access your application, but you always need to ensure that the end user experience is pretty good. And then, of course, now the third, which, if we consider the 3D cube, X, Y, Z axis, the Z axis is time, right? With these two, it becomes harder to manage the time, right? So now, that's where you need to kind of draw that middle ground. Okay, what is the amount of risk I'm able to take? What is the breadth? And how much time do I have, right? So this is basically being able to identify what is that I need to do as part of my continuous testing. All right, now that we understand what continuous testing is and how it is different from test automation, let's look at the basics, right? So this is what I call the school of continuous testing. I'll be talking about 12 disciplines today. These are things that you can kind of take away and see as part of your testing, are you adopting these principles, these disciplines, right? So again, a lot of examples that I am going to be giving today are based on Microsoft technologies. But again, it's not limited to Microsoft technologies, right? So it doesn't matter your technology, your platform, these concepts will hold good. The first discipline is basically requirements engineering and acceptance criteria, right? You need to ensure that you are including all the SDLC stakeholders in this continuous testing journey, right? It goes back to that first question I asked. Who needs to be involved? And I think most of you got the answer right. Everyone needs to be involved. Testing and product quality is responsibility of each one of us, right? You must be able to utilize better way of being able to communicate and collaborate on the requirements. There could be clarifications that are needed for requirements. If you're still living on emails, Word documents, there are better tools out there in the market, right? Next, the acceptance criteria. This is very, very important, right? Being able to define those acceptance criteria, and then you need to be able to create those tests based on acceptance criteria. In fact, there were a few years ago, right? There were a couple of things that became quite popular. One is called TDD. Anybody who has done TDD? Test-driven development, behavior-driven development, yeah. Again, I'm not suggesting that you follow test-driven development, but there is a lot of value in following certain concepts of test-driven development. For example, being able to map all your test cases back to your acceptance criteria, right? So that anytime something changes in the acceptance criteria, then it automatically triggers an alert telling, hey, your test case has to change because the acceptance criteria has triggered, right? You need to be able to basically build that traceability, yeah, between your test steps and the acceptance criteria. And then again, if you really look for it, there are ways in which you are expected to define the acceptance criteria, right? So there's a lot of material around how to write my user stories, how do I define my acceptance criteria. So my suggestion is go and look for it. Next key aspect is unit testing. So as developers, how many of you do unit testing? That's good. And how many of you can get 80% plus code coverage? Brilliant. Okay. So again, unit testing is quite important. In fact, it's super important. Unit testing by itself, right? I mean, it's something very simple to write, something very small. Individually, their effect might be small, but collectively, right, as a large number of unit tests, the value it provides to testing your software is huge, right? So here, you need to select the right set of tools. You need to define what your unit test framework is. If you're a .NET developer, we have a framework that's provided right out of the box for you. You'll also need to define your isolation framework. What is it that you use for creating your stubs and mocks, right? So here again, if you're from the Microsoft world, we have something called as Microsoft Fakes. There are a lot of other tools, right? Mock, MOQ, RhinoMox, so there are different set of isolation frameworks that's available. You also need to be able to get your code coverage reports. So there are, again, tools that are built in. There are tools that can be built into our DevOps pipeline that can act as quality gates. So if you don't hit that particular criteria, maybe you as an organization right? Set up 80% as the minimum for your code coverage. If you're not hitting that, the quality gate is automatically going to reject your commit. Yeah. Then, of course, in Visual Studio, we have something called as Test Explorer, which kind of gives you that nice dashboard telling you, okay, these are all my unit tests. You can run your tests. You can debug your tests, right? And the next important aspect when it comes to continuous testing is being able to create those environments on demand, right? So today, with the advent of cloud, this is something that's become super easy. I still remember, this was probably about 6-7 years back. I was working with a customer, and we had built this new application. We had a go-live date, which was 3 months into it. And we basically had to do a performance testing. So I get into this meeting with the performance team. And basically, we start discussing the timelines. And the performance team says, hey, we have these many number of devices, hardware, servers. This is what we'd be using for loading, and this is what we'd be using for creating this environment. However, since we do performance testing of different applications, for me to create an environment and do this, we are at least a couple of months away, right? So next 2 months, I cannot create an environment for you. I cannot create a rig that can basically add all that load, right? So they say 2 months, but our timeline is within 3 months. What do we do in such scenarios? So today, we don't need to worry about any of these, right? So we can create environment on Azure whenever we want. There is also a very high level of parallelism organizations are creating. So earlier, right, we would talk about QA environment, right? It was singular. But today, it's become plural. We talk about QA environments. Different versions of software we could be running in parallel, right? And testing it in different QA environments. Or within the same version, we could probably run these tests in parallel, right? So you can basically create and tear down your environments because of the new agility that has come in terms of agile and scrum processes where we have, 2-week sprints now? Yeah? So we need to be able to do this within that short amount of time. And then, of course, we also have the ability to express our infrastructure, for us to enable to create and tear down environments. We can express our infrastructure as code. We can create ARM templates in Azure. You can use things like Terraform as well. Another key aspect of our continuous testing journey is test and test data management. Being able to write the right set of tests and data, right? That is crucial. We'll also need to have enough diversity in our data. We need to be able to test all the negative scenarios. And another key aspect that we are seeing today is the synthetic data generation, right? Often what happens is, so again, another incident, right? Again, this kind of goes back to unit test. So I was talking to a developer who says he had written a unit test and it's getting extremely good amount of code coverage. He was telling somewhere about 50 to 60%. I was surprised, and I asked him how many unit tests had he written, and he said he had written like 3 or 4 unit tests, and it was giving him a really good code coverage. I was like, okay, what's really going on? It turns out that what he was doing is he was calling into one of those high-level methods, which internally was calling into multiple other methods, calling into database, and then fetching this data and basically doing that, right? So then I kind of told him, this basically beats the purpose of unit testing. With unit testing, you're actually testing a small piece of code that you're writing for the business logic. That's where you would use tools like mock, right? I mean, you cannot have the dependency on database. You cannot expect that kind of a data to come at all the time, right? Whatever data you're looking for in the database, that might be there, might not be there. Why are you building that dependency? Also, in terms of the time, right? Unit tests are supposed to execute quite quickly. Now, by building this dependency on database, ensuring that this particular data is sitting in the database, you're also, when we're talking about this continuous testing cycle, right? Time is of essence, right? So now making those database calls is going to slow down your suite of unit tests. So here again, there is this importance where you should be able to synthetically generate this data as well. So again, there are tools for generating synthetic data. how many of you have seen this pyramid, when it comes to test automation, right? Yeah. So what it basically tells us is write as many unit tests as possible, then you would actually do API testing, and then you would do UI. Because what happens is the amount of time and effort that you spend on writing UI tests to the value that you're going to get out of it is much lower. Rather than rather you can write more unit tests and more API tests. So someone asked me, what's a good ratio? So typically you can say 1:10:100, right? So for every UI test that you write, coded UI test, question?
What's your opinion on the other sectors like the testing diamonds instead of that, like having more integration tests and less maybe end-to-end UI tests and also less unit tests?
Right. So the question is the testing diamond, right? I mean, so another philosophy is creating that testing diamond. So what's my thought? Again, I haven't really worked on the testing diamond aspect to really comment about it. What I'm not clear is what do we have on the bottom side of, if we were to consider it as two pyramids, what do we have here?
And UI would be less, maybe UI certainly less than units, but more integration tests for your scenarios, which aligns more with BDD and having full scenarios for the business, like you can get more value.
Okay, so that's a good conversation. Again, maybe we can discuss it offline. Again, I'm not very familiar with it, but yeah. Again, kind of coming back to this test automation pyramid, strive to do as much test as possible with the unit test and the API tests, and minimize the reliance that you have on UI testing. Another key aspect of your continuous testing is being able to run performance and load testing as part of your pipeline, right? Here again, right, use the power and scale of cloud to generate the load, right? So you might be creating a global site. With your existing data center, you were limited to whatever data center location you have to generate all the load that you want. But whereas with services like Azure, you can generate load from pretty much any geographical region, right? So utilize that to your advantage. And then again, for doing performance testing, load testing, there are many free and commercial tools available. There's like Apache JMeter, that's one of the most famous one out there. Here's a little sad note though, which was an announcement made a few months back. How many of you here have used the performance testing that's available within Visual Studio? Anyone? Okay. So unfortunately, that's going to go away. So we had a very similar feature called as cloud load testing. That was part of Azure DevOps. That's going to go away as well. So those of you who were using it as part of your pipeline, so these two are going to go away, but then yeah, there are many other free and commercial tools available like Apache JMeter. So ensure that you are building this as part of your pipeline.
Is that a replacement for Azure Monitor?
No. So the question is this a replacement for Azure Monitor? The answer is no. We are still talking about the performance and load testing. Monitoring is something that I'm going to talk a little bit later. Yeah. Very, very important, right? So security testing. In fact, this does not deserve one slide that I have. This particular session, I mean, this is like a whole big topic, right? I mean, people can talk about security testing for hours together, right? So it's, in fact, it has its own terminology as well. It's called as DevSecOps, right? So application security is super important as well, right? This area is, again, evolving. There are a lot of things that you can do, right? For example, from your application, let's say, in today's application, right, you are dependent on a lot of third-party libraries. You'd be using NuGet packages, you'd be using NPM packages, right? So what happens if there is a vulnerability that's discovered in one of these packages, right? So always ensure that you set up security alerts. For example, GitHub has a support for alerting on any dependency that you're using. Ensure that you are integrating this as part of the quality gates, as part of your pipeline, right? In fact, let me show you the next diagram as well that will give you a better picture of that. ensure that you're setting up pipelines to run static analysis. So a lot of static analysis can find out security flaws. Dynamic analysis, software composition analysis, these are all key things that you must be doing as part of your continuous testing, right? Again, security testing should happen in every stage of the application development lifecycle. And also, when it comes to pen testing, penetration testing, right? You can automate as much of penetration testing. So there is always a value of having someone to do penetration test manually. But there is a lot of it that you can still automate. There are some really great tools out there in the market. There is one such tool is called as OWASP Zap. I don't know, has anybody tried around with this tool? Zap, yeah. So ensure that you automate it. Are you doing it as part of your pipeline? Okay. So yeah, so again, try and automate it as much as possible, right? So this is basically one of the diagrams, right? So which kind of talks about the pipeline, how I would kind of get the feedback, where do I identify the open source dependencies, vulnerabilities, violations, right? So I'm pretty sure we'll be sharing the slide. There's also a URL, so feel free to look at this, and this is one way of building it. Again, this is at a high level, so this is a good starting point, but then you can go and refine it as much as you want. Next is test automation. Test automation is a key piece, right? Again, test automation is not equal to continuous testing. You need to start your test cycles early. You can build a lot of automation right from your unit tests to your API tests to your UI tests, right? So even for UI, there is something like Selenium, right? Anybody using Selenium here? Fantastic, right? So again, follow the pyramid model to build and automate your UI, API, and your UI, unit testing. And then the next key idea is also to create tests automatically, right? It's called as automated test generation. In Visual Studio, we have IntelliTest. So you can use the tools. But there again, right, for you to automatically generate the tests, this is a good starting point. But then you can actually go and create more tests surrounding that, right? I mean, this is just a good starting point. Another key aspect of continuous testing is pipeline orchestration. Again, your pipeline must be integrated with your automation suite. It's important that you understand, not just you understand, be open and transparent about it. So ensure that everybody in the team understand how the pipeline functions, what the quality gates are, right? So always ensure you create it. And then another key aspect is the deployments, right? A lot of these things are supported out of the box on Azure. Anybody here who has used Azure App Service? Yeah, so if you're familiar with the concept of slots that we have in App Service, right? It actually provides a lot of these functionality. Have you heard of A/B testing, testing in production, any of these? Yeah? So A/B testing is kind of quite simple. So the easiest way for you to remember A/B testing is, this is something that's done by a lot of marketing companies, or even when you're releasing a new software, right? So just imagine you want to place an ad, right? Again, I'm just giving you an example. Is it better to place an ad on the left side of your web page or on the right side of your web page? How do you go about understanding the layout of your site? So maybe the requirement says just place it on the top, but is top the best place to put all the ads on your web page, right? So what you can do is you can actually do something called as A/B testing. If you're trying to compare between left and right, and let's say you have 2,000 users, you can say for 1,000 users, everything else remains the same, but the ads are placed on the left side. And for another 1,000 users, everything else, the functionality, everything remains the same, but the ads are placed on the right side. Then you can use tools like continuous monitoring, the feedback, in order to obtain who is clicking on more ads, right? If the ads are on the left side, are you getting more clicks? Let's say if it's on the left side, you're getting 50 clicks out of the 1,000 users. Whereas if it's on the right side, you're getting 30 clicks. Then you know later that you always want to put the ads on the left side, right? So that's called A/B testing. So you can actually achieve that using features that are built into the platform like Azure, like App Service. Then there's also blue-green deployments. How many of you have heard blue-green deployments, aware of it? Fantastic, right? So here again, right, the staging slot. Again, staging slot conceptually is not different. So even though it's provided as part of App Service, we have always come across this in enterprises, where we always have a set of servers running the previous version or the next version and ready to make that switch, right? Should something fail, we know, okay, this is where we need to get back to, right? So again, that's possible. Here you can actually see, right? In the production, we have deployed to staging slot, and then you can swap the staging slot as desired, right? Then there is also this concept of canary releases. So the idea behind canary releases is, it's also called as deployment rings. Whenever you're rolling out a new change, what you do is you roll out to a subset of the users. We actually do that as part of our Microsoft Office as well, right? So whenever we roll out a new feature, we roll it out only for 20% of the user base. We leave it that way for a couple of weeks or so. If the feedback is pretty good, then we go and roll it out to rest of the user base. So this is basically deployment rings, right? So canaries, early adopters, and then we finally go and publish that new feature to the users. And then the last but super important concept is continuous monitoring, right? So continuous monitoring, again, going back to the question that gentleman was asking earlier, right? So it is, again, something that you do across your SDLC, and you also do it in your production once your application goes into production as well. In Microsoft, we use also something called as automated runners, and to identify certain issues, right? So often what happens, you do some kind of a testing as soon as your application goes into production. You do things like BVT, smoke test, whatever. But often there are certain issues that kind of manifest after your application has been running for some time. It could be, typically these are issues around memory and stuff, right? So that's where we use the concept called as runners, basically that perform CRUD operations, insert, delete, and some of these operations, and then goes through a simple user flow as well. So yeah, that's something, and continue to monitor. In fact, there was another very, very interesting topic that I heard. This was actually one of the sessions that was presented by Brendan Greggs from Netflix. He is the chief performance architect at Netflix. So he was talking about how monitoring actually helped solve one of their issues. So basically what they were seeing is in the CPU cycles, right? Again, they were just monitoring the CPU cycles. Pretty much the load was about 80%, but then there was a sudden drop to 30%, and again it's back to 80%, right? So they were actually seeing this in the graph. So there were two things that could be happening. One, okay, there is some kind of a performance issue. Second, maybe the users were switching off, right? Because Netflix is a global media streaming service. There are a lot of users joining in, logging out and stuff. So maybe that. But what they recognized is this pattern was happening quite often. So then actually they kind of went into it. And most of the time, right, we get a minute average of CPU cycles. So he was like, how do I go into much more detail? And he actually created a tool called as, it's called as sub-second offset heat maps. So basically, it kind of gave him a picture of what's happening within a span of a second. And that's where he actually saw that the CPU was basically utilized at 0 for 500 milliseconds once he started getting into the sub-second report, right? So even though it was showing as 30%, which was average per minute, in 1 second, for 500 milliseconds, basically the CPU was 0, right? CPU utilization was 0. So, and then further, they also, Netflix have created an open source tool. I think it's called as Flamescope. I think that's what I don't know if anyone's used that, which basically then gave a nice graph of, okay, where the time is being spent. And they actually found that there was one thread that was obtaining a lock, and all the other threads were waiting on this particular thread, and later they were able to resolve that issue. But again, monitoring really helps, being able to go into that extra detail, right? Not just looking at those 1 minute average. For you, with the hardware, you need to be able to extract every little bit of juice out of it, right? So monitoring is, again, super important. So there we go. We spoke about 12 key disciplines of continuous testing, right? So this is what we kind of spoke about today. Hope you can kind of incorporate this. And one such tool that can help you from the Azure world is called Azure DevOps. Anybody using Azure DevOps here? Awesome. So a lot of these principles that I spoke about today, right, the 12 different, you can accomplish that using DevOps. And DevOps is such a tool that you don't need to actually use everything of DevOps, right? So for example, if you're using, let's say, Jira, right? So you can continue to use Jira. You can go as much as you want, or you can go all in and extract all the benefits. So Azure has Azure Test Plan, which lets you run all the tests. Within Azure, we also have something called as DevTest Labs, being able to create that on-demand environment, right? So you can utilize DevTest environments. For expressing your infrastructure as a code, right? Again, today it's super important, being able to spin up and tear down those environments. You can write using ARM, which is the Azure way, or if you're familiar with some of the other open source ways like Terraform, Chef, Puppet, feel free to do so. They're all supported. Continuous security, we have a tool called as Azure Security Center. It also has ML on top of it that can give you alert. It can do proactive monitoring and give alerts. And for the insights, right? So we have something called as application insights. We also have Azure Monitor and Log Analytics. Again, you can set these up for monitoring your applications. Yeah, so basically with Azure DevOps, you can choose the tools and the clouds that you really love, right? So not only on Azure, we also support AWS. So even if you're doing deployment on AWS, you can still use Azure DevOps, maybe parts of Azure DevOps to get that end-to-end traceability. Think of Azure DevOps as something that can bring everything together. All right, with that, here is the summary. The art of testing is like studying for PhD, right? I mean, the more you learn, the more you realize, that there is so much more to know. Just like, how I learned about the testing diamond, right? So now we know what the answer for this question is. All right, so let's break the software before it breaks in production. Any questions? Yes. And please provide your feedback. You can scan this. If not, you can use the URL below. Yes, questions?
So in Phoenix project, there's this concept of chaos monkey also.
Yes.
What are your suggestions when it comes to Azure DevOps?
Very good. I'm glad you brought. So the question is, there's also this concept of chaos monkey, right? So the reason I actually did not include in my 12 principles or in the school is because this space has not matured enough. I know recently there was an article where they spoke about being able to integrate Chaos Monkey. So for those of you who are not familiar with Chaos Monkey, it's basically it's letting like a wild monkey on the loose that goes and brings down parts of your application down, right? Parts of your infrastructure, maybe bring down one of the server randomly, right? So this basically kind of simulates a real a world disaster where something kind of just goes down, right? I mean, a few years ago, right? I mean, whenever you ask a developer, hey, there's an issue, right? He would say, go check with the networking team. It was nothing to do with my code. It was the network that was down, right? But end of the day, the business is at risk. And how do you determine this? What happens to your application if one of the underlying foundational infrastructural pieces goes down? That is where you would use tools like Chaos Monkey in order to bring down something, tear down something randomly and see the effect of that on your entire application, right? So now coming to Chaos Monkey or tools, I think that's part of, what is the tool set that they have? Chaos Monkey is part of that, right? It's called Simenami, right? So there has been, again, in terms of using the chaos engineering, I'm totally for it. It's absolutely, it's going to help. But when it comes to continuous testing, I don't think it is matured enough at this point of time to incorporate that as part of your pipeline, right? But recently there was an article, again, I haven't really played around much with it, where they were talking about being able to utilize something like Chaos Monkey with one of their CD platforms. What's that CD platform that they have? The Gremlin guys? Okay, so they have their own CD platform, and for the first time, they were able to integrate Chaos Monkey with their CD platform. I'm sure that's a space for you, everyone, for all of us to watch out, because that's, yeah, Chaos Monkey is from Netflix, right? So what's the CD platform that they have? Yeah, it's called Spinnaker or something of Spinnaker, yeah. So they have integrated Chaos Monkey with their platform. I'm sure this is a exciting space for you all to watch out, because I'm sure we are going to have something to perform chaos engineering within our pipeline soon. Yeah. Any other questions?
Just wondering, the slide deck is going to be published.
Yes, Simon. When is the slide deck going to be published?
Whenever you like us to publish it.
There you go. Next 10 minutes. All right, any other questions?
I think the disciplines of the principles we all acknowledge, right? But one of the challenges we see
Mhm.
by organizations, people, culture, and mindset, right? What I have seen at Azure, everyone is working these principles because we have
and I used to hear this message a lot. And tell me if that sounds familiar for anyone. My application was working well on my machine, but when I moved it to the IT team, it's not working well. Who have said that? Most of us, right? Yes. So as a developers, all we care about is just writing our code smoothly, having that running smoothly in our servers or any servers. We just care about having our code running, right? So this happens a lot, that developers get frustrated and they think their productivity gets suspended because they are always waiting for the IT. So developers always say, I can be doing an amazing things, but IT are slowing me down. Then you go and you chat with the IT guys, the poor IT guys. They just got a bunch of cowboy developers, keep changing stuff all the time, keep changing the platform, keep changing the application and the dependencies that needs to be installed in the server, in the production servers. And actually, IT, what they care about, they just care about the server's uptime and reliability and the server's stability, right? And changing stuff all the time that definitely break the server's uptime for them. So IT, usually what they get from developers, they get a bunch of different applications that they need to run together in one server. They don't know how to do that. They usually go back to the developers and ask for help. And they're not able to focus in the thing that they need to do, right? So what is the answer for that? DevOps now is the answer for everything, right? But we're not talking about DevOps today. DevOps requires a culture change. DevOps is a great thing, and it's definitely a solution for that. But we're talking about containers today. So containers is what will make the IT team happy and the developers happy as well. This is what's going to solve this problem. Having your applications running well or running the same way as it's running in your dev machine and in the production machine. So it definitely saves time. It saves resources as well. It reduces the downtime for the IT team. It makes everyone happy at the end. So this is the agenda. This is what I want to quickly cover with you in the next 45 minutes. We'll have a quick intro about containers, what containers are, a little bit of history, and a quick intro about the workflow for developing containerized applications. Then we will talk about containers in Azure and the different solutions or offerings that Microsoft have for running containers in Azure. There are lots of different services, and it's super important to know which service to use when. And that's what I want to cover mainly on today. We'll talk about the different services, and we'll focus on different use cases when you should use those services. Then we'll have some demos after that, and finally we'll cover how you can run and scale your containers and orchestrate. You're all in the right session today, just because Gartner's claimed that by 2020, 50% of enterprise organizations will run their applications containerized in productions. So I would say here it is safe to say that containers is one of the early adopters for modernizing applications, for one of the very early steps in the digital transformation journey for any organization. So it's super important to know what's container and how to use it. So before we move on, by the show of hand, who use containers today? Awesome. Who use containers for modernizing .NET applications? 1, 2. Who use containers for modernizing applications on-prem, whatever they call it, on Azure? Awesome. So it would be a great session. You'll learn a lot about that today. Who think that Docker have invented containers? Let's dispel that notion. People think that Docker have invented containers. I have heard that a lot. But actually that go all the way back to the 70s, to the Unix, where we had the CH root, that concept of isolating applications where you run your application in a jail and whatever outside that directory or that tree can't access it. So That's where the containers started. It's not something new. It's not a new technology. Then we got a bunch of innovation. Then in 2006, we got the Linux containers introduced. Then in 2013, this is when we had the Docker containers and all these containers ecosystem that we're currently living in. So before we talk about the services, let's just cover some basics. What are containers and what is the difference between containers and VMs? I believe you have all seen that picture before, that layer cake image. We are all familiar with VMs, right? We know what's a VM. We have an infrastructure, your hardware. On top of that, you got your hypervisor, and you got the host operating system. Then on each virtual machine, you got the guest OS. And on top of that, you run your application with its binaries, right? But what we do in VMs to keep things simple, we separate applications on VMs by running applications in separate VMs. And this is how we separate applications. So if you put multiple applications on the same virtual machine, they're not going to run well, right? If they are using same shared libraries and different versions, this will not work. So when it comes to containers, and that's a great value that containers add here, you got the same, you got your hardware. On top of that, you have your host operating system. Then you got your container engine. And what's the container engine is simply a software. And that software what enables you to run containers on this machine. So what actually running in the container, there is no operating system running on the container. It's only your app and its binaries. So your application and its dependencies bundled up in a container. That's what is inside the container, and that's what makes it very fast and lightweight. So to add a technology name on top of that, your container engine, that's Docker. So Docker is simply, that's the software that you run to be able to containerize your applications. Who knows the difference between little d Docker and capital D Docker? Anyone? Some people get confused about this. Little d Docker, this is the open source community-driven project, and that's the container engine. That's what we all use. And we have capital D Docker. This is the company that built these enterprise add-ons that we all use around that open source project. But actually, the company, Docker, they don't have full control or access to that. They don't control that open source project. So one of the great benefits here about containers, and that's what makes it different than virtual machines. If I have application A here and application B, and both of them are using the same shared library, and then application A decided to use different version or a newer version of that, this is not going to affect the other application because each one of them have its own copy of that library. So each application have its own dependencies inside that container. So one of the great advantage about container is the way that it isolates applications. So this is the great benefit about running your applications in container. That's what makes it different. So if you are across different technologies, for example, if I'm a Java person, I could be deploying jar file. If I'm writing open source, I could be deploying tar file. In Microsoft world, we have DLLs and we have EXEs. It is lots of manual labor to go and know how to bundle these things up and move them from server to another, right? So that's what makes containers here adding a great value to the way that you move application from server to another. You ship everything in your container, and all the platforms that you now support Docker standards, and your application gonna run the same way in all platforms. Does that make sense? So, last thing I want to cover here in the introduction about containers is the workflow. How you can build a containerized app. We got our developers writing their code, whatever language you want to write. You could be writing Java, Ruby, .NET Framework, .NET Core. So you wrote your code, you wrote your application. Then after that, you want to containerize that application. So to containerize your application, you need a Docker file. And what Docker file is just simply a recipe. This is just the file that contains some steps to know how to build that container. You define the base image where you want to read to the platform, where you want to run your application on top of it, and set of commands that you want to run. For example, I have here, I'm just copying my compiled code, then after that, I'm running .NET Core DLL. This is just a very simple example, but in real world scenario, you might be doing more stuff, but you prepare your Docker file, and that's it. There is no difference between the way you write your applications to have it containerized. All what you need is just to know how to write that Docker file. Then after that, you create your image out of that Docker file. Then after I create the image itself is not a container. The image is just something like an instance of that container. So you build your custom image, which is the base image that you pull down, and whatever you have added on top of that. Then after that, you create the image and you run the container out of this image. So in this example, for example, here I'm running that container in a virtual machine. Then after that, I can just test my application if I'm happy with that. Definitely, most of organizations now would have a CI/CD pipeline for that. Then you can just push your container to production or to test servers. If you're not happy with that, you just go back to the development again and go through the same process. So the only difference here is just the Docker file.
So are we doing all the development in virtual machine currently, and then we're creating the image out of that development for container?
Yeah, so the example I have here, the virtual machine here, this is just where I'm running the container itself. So at this step, I'm here in my development machine. I open Visual Studio, I wrote my code, I prepared my Docker file locally on my machine, and that's what I will show in the demo. You run your you run your Docker commands to build your containers, and that's still happening in your development machine. Then you push that, you build that to create your Docker image, okay?
Can a container be a development machine?
Can the container be in the development machine?
Isolation, like development machine as container. Can't be like that.
I didn't get the question.
I thought it's a subset of virtual machine actually.
Yes. So for example, in your development machine, you can run containers in your development machine. Does that answer your question? Yeah. So the example I have here, I'm working on my dev machine, and I have created my container, or I have created my custom image. And here, I missed to say that after you create the image, you need this introduce a new concept here, the registry. Like what we all use now, we use GitHub, right? To save our code and as a repository. So you need here a registry for saving your container images. And that's where you can share those images with the other teams or with the world.
So every time we change the code, we need to go back and create the image.
Very good question, yes. So every time you do some changes here, you have to go through that process again, because whatever you build, your code in that last thing, that's what will be inside the image. And you push that image to a registry. So if you want to add more changes, you need to just build the container again, and it's just one command. Any other questions before we move to the next section? Cool. So we had a quick intro about the containers and the workflow. Let's talk about Azure. Let's talk about the different ways you can run your containers in Azure. So if you have a preference environment that you want to run your containers on, you can get your environment, like if you are using OpenShift or Cloud Foundry, you can still run that in Azure. There is lots of offerings in the marketplace. Or there is lots of ARM templates, and this is the templates that you can provision, the infrastructure that create this environment for you. But this is not what we are talking about today. if there is no preference, and usually that is the case, you should be selecting the solution or that you will run your containers on based on your application needs. So these are the services that you can run your containers on in Azure. We have App Service, Azure Service Fabric. We have Azure Kubernetes Service, or AKS. We have ACI, or Azure Container Instance. We have ACR, or Azure Container Registry. So lots of things, lots of offerings, lots of services, but each one is meant to be used in certain situations. And this is what I want to focus on today, the use cases, when you should use which service. So let's just start with ACR. And as I mentioned, this is just a registry. This is like Docker Hub or like GitHub, but for saving your, this is your repository for saving your container images. It is registry as a service, so it's suitable for any enterprise scale organization. You can have it public or private, but what makes ACR unique, and this is because it's running in Azure, that it got this integration with Azure AD. So you can use Azure AD for that piece of authentication and control who can have access to your repository. So that was ACR. Some people think when we talk about running containers that they have to be in VM. Who think that? Anyone? Yes, I felt the same when I started. So your containers doesn't have to be on VMs, but this is one of the options to run your containers on VM. So when you should use that, that's similar to what you do on-prem, to what you do in your dev machine. So there are some offerings in the marketplace, in the Azure marketplace, where you can get the image with the Docker engine installed and all the tools needed. Or you can just provision a VM and install your tools on top of that. But when you should use this should be used if you are doing dev test scenarios. So for example, you have your application containerized and you just want to see how it runs. Okay? So this is one of the scenarios. And when this is not, why this is not suitable in a production situations? Because this is not very scalable. And we'll talk about scalability later. So this is mainly for dev and test, or if you don't have an on-prem server and you want to run that on the cloud, or another use case for this one, and I have seen lots of customers doing that, if you are already doing that on-prem and you want to go with that easy lift and shift option and you want to have your VMs that's running already on-prem having containers, you just push that images or VMs to Azure. So that's when you should use VMs. Another option is using App Service. So App Service is Microsoft offering for running web apps from small to enterprise scale applications. It supports containers as well. One of the great things about running containers on App Service is that you get all these great features about App Service. So the CI/CD, the deployment slots, the backups, the geo-replication as well. So when you should use App Service? App Service is mainly for, if this is ideal, if you want to migrate .NET applications directly to Azure, and we want to go with a PaaS offering. So you could have a large monolith application and you just want to push that to Azure, you can run that on App Service. If you have a simple app that's part of a microservices application, but it's a simple application, you can run that in App Service. And by saying simple here doesn't mean that it doesn't scale. App Services scale very well. But your application will be running in single containers. So use App Service if you're running application that can live in a single container or simple apps. Correct. So App Service is a PaaS offering. So it is platform as a service. And what's really great about that, You don't have to worry about VMs. You don't have to worry about infrastructure. You just go there and you create your application in Azure. It could be a function app, a web app, or API app. And what actually happens in the background once you push your code there, we run that code in a pool of VMs, and you decide how much power you want to be dedicated to that application, and that's how we separate the code from the infrastructure in app service, and we call that app service plan. So you decide how much power or compute you need, and we take care of the rest. Yeah.
So why would we use container in app service or .NET?
Yes, so in app service you have two options. You can push your code directly, or you can push your containerized apps. So the difference between both, if this application, for example, like the example I gave, if you have a large monolith application that you have and you want it to be containerized, you can push that in app service. If you have a legacy application containerized, you can push that to app service. App service recently, but this feature is still in preview, it supports multi-containers as well. So it's not only for running single or simple apps. You can write your compose file with multiple containers, but the downside of that, or it depends on what your application actually needs, that each application will be running in single container. So if for example, when your app services scale, each container will be scaling separately. Does that answer your question?
That's
Like virtual application? What do you mean by virtual application? Yes, something like that, like multiple containers. So app service is meant for simple apps. Yes?
Can container access file structure of another container or host virtual machine?
Container of another container, that could be done in app service with multiple containers, and you can do that with the Docker Compose. But you would have to write that in your Docker Compose file.
And also, like the host virtual machine, which is hosting the container, can you access the file structure of the host virtual machine from the container?
And the container is running in app service?
Yeah, sure. But in a virtual machine, sorry.
So you have a virtual machine, and you have your container running on that virtual machine. Okay.
Can you access the file structure of the virtual machine?
Yes, that's what you do in the Docker file. With the port mapping, for example, there are multiple directives you can add in that Docker file, like you map ports, or you can attach a persistent storage, or you can share files from the host machine itself. So this is the steps that you add in your Docker file when we talked about the workflow. So moving on, we have Azure Container Instance, and ACI is another super easy way to run containers in Azure. It provisions in few seconds. What makes ACI unique is it's micro billing. So the billing in ACI is per milliseconds. So it is great for bursty workloads. So use ACI, still it is for single containers, not for microservices application. If you have a single container that you want to run quickly on Azure and you want to shut it down after that, use ACI. This is the fastest way. In few seconds, you can have your container running. When you should use ACI if you are doing a data science and you want to run your container with high compute power. That's what ACI for. It's also used for dev and test if you are building a CI/CD pipeline of a containerized app, and you want that application, you want to toss it to an ACI to run automated tests, for example. That's when you should use Azure Container Instance. So this brings us here to the demo. Let's see how easily you can run your containers in App Service and ACI. So I'll stop presenting here. And I have an application. I was trying to be cool, and I pulled an image of a Mario game. So that's my application. To containerize, it's just a bunch of HTML files and JavaScript. So to containerize that app, I have added the Docker file here. So let's see how easily we can do that. So first of all, I will start the workflow from the beginning on my machine. I have the app, I have the Docker file, so let's build that app first. So to build that app, you just write Docker build, and all you need to do for that, you just install the Docker tools in your machine. After that, you can run the Docker commands. So I'm just building that application locally. It's just 2 commands. I'm gonna build it, then I just run and test that locally. Then after that, I just select here a port where I want to access that on my machine. So Docker run, I'm still doing everything locally on my machine. So now I did build the app, and let's open the browser and see if we can access that. Localhost, I have copied the port, 8999. Yay, my Mario game. Let's see if it's working. If you have any questions about containers or how to play Mario, you can ask me after the session. So this is just a very simple command. That's all what you need to build and run container. So now the container is still on my machine. So let's create an image of that container and push it to ACR. So to do that, just to save our time, I just have prepared the command earlier. So I'm just gonna cheat. So first of all, I will just log in to my container registry. Then what I do here, I will just tag the image and just push it to ACR. That's it. I'm just giving it a name, and that's the name that will show there in ACR. Anyone want to give me a number between 0 and 500? Anyone? 500, okay. So my image name is Super Mario 500. So that's just the tag, that's the name. Then
These tags are auto-generated or
yes, that's the tag. That's the tag that I did just add here, and that's my container ID. When I did build the container, it gave me an ID, so I'm attaching that tag to that container ID. And I'm just pushing the same container, Super Mario 500, Docker push to my container registry. So it's now pushing, and actually it just mounted that from a previous image because it's just got the same ID. But let me show you that. And that's all what you need to do to push your container image to the registry. So if I go to container registries here and go to Bootcamp 2019, go to repositories. So Super Mario 500, this is the image that we just pushed now. So let's use app service to run that container. So app service, as I mentioned before, this is a PaaS offering, and that's great thing that you don't have to worry about patching servers and updating the versions of the software that's running on the machine. We take care of everything for you. So let's give it a name, Super Mario 500. I will select the subscription where I want to run that. And let's create a new resource group. Let's call it Super Mario 500. So this one, I know it's Linux. And back to your question about the code, someone asked here. Oops. Time out. So someone just asked about why I should push my application to container. So those are the two options. You can just push your code directly here, or you can push your Docker image. So if your application is containerized, and that's for lots of different reasons that we have covered on the start, you just select Docker image here. And
use capital D, not small d.
yeah. So the small d, that's the open source project. And the one with capital D, for example, that's their add-ons. So it have their logo name, Docker. So Docker is just pushing lots of add-ons in the market and lots of tools to use around that open source project. So as you can see here, I'm just selecting the container registry. So I have selected here Bootcamp 2019 and the image that we just pushed together, Super Mario 500, version 1, apply. And imagine, that's it. This is all what you need to do to run your container and app service. You have it pushed to a registry, and by the way, when I selected the registry here, you don't have to use ACR, by the way. You can read from Docker Hub, or you can, if you have a private registry, if your company have invested in another registry, you still can use Azure and run your containers in Azure. So I have selected ACR here because I push my image there, and I hit create. That's it. That's all what you need to run your container in app service. It takes few seconds or almost a minute to create. So while it's doing that, we go back here, still deploying. And that's it, deployed. So I don't see VMs, I don't worry about the tools, I don't worry about anything. I just pushed my code and I have an endpoint to access that. It should show something here shortly. Yes. So that's the URL for accessing my application. Take some time for the first request. But while it's loading, this is the goodness of running your apps in app service. You got, for example, the deployment slots here. So deployment slots, I know this was covered in the previous session, but quickly deployment slots. This is like an environment running side by side. So you can have dev, test, prod. And once you're happy with the version of your code that's running in the test slot, for example, you just swap the slots from test to prod, and it's just a DNS swap. So there is no downtime. And that's what organizations use the deployment slots for. You got backups, you got the identity, you can integrate with Azure AD. You have the scaling options here, and this is what we covered about the app service plan. And that's how we separate the hardware from the application where it is running. So with the app service plan, we decide how much power or compute power you need to be dedicated to your application. So I see the app did load. So yeah. So I have my application ready in less than a minute on app service. Let's see the same on Azure Container Instance. So I'm going to container instances. I want to show you quickly how you can run your containers in Azure Container Instance. So in Azure Container Instance here, this is the information that I would need to fill in to run my container in Azure, container instance. I'm going to select one of the previous resource groups. Container name, let's say ACI demo 2019. Did I use that name before? 04. It's lowercase. Yeah, it's not happy with the uppercase. Demo 04 2019. So that's my container name. I want to run that in Australia East. You can select here from a public or private registry. If your image is public, you just put the URL there, the name with the tag there. If not, you select private and you fill in this information. So for example, you got the login server, the username and password. So if I go to the ACR again, let me just open a new tab. Portal with Azure. So if I go to Azure Container Registries, and that's where I pushed my Mario image game. So here in the repositories, if I go to Super Mario 500, or actually the repository itself, if I go to access keys, that's where you get this information, the login server and the repository name and the password. So you copy this information and you paste it there and that's it. So, but just to save some time for our demo, I'm gonna use one of the public images. I have saved that image name somewhere. But it's typically the same. You just put your image name. If it is private, you just give the credential needed to run that. Then next, DNS name, let's say ACI demo 04 2019. Click preview. It's going to validate the information that I did just enter here, and I hit create. And again, that's it. That's all you need to do to run your containers in ACI. It's super easy. It takes really few seconds to provision your containers. And you don't see VMs, you don't worry about infrastructure. All you know that you got an endpoint and you can access your container using that endpoint. So we have the counter here. Let's see how many seconds it takes. Sorry, I missed the.
So in app service.
In app service.
Yeah, you have an integrator where you can choose which registry you want to choose an image, but ACR you have to put a login. So when
Yeah, I had the same question when I'm preparing for the demo because it's super easy in app service, like all the information there, but in ACI, you have to manually put the information. Yeah, sometimes it's more like adding more features. So for example, ACI, because if you have a private registry, you would have to do the same. But yeah, makes sense. Because the registry in Azure, but still you have to fill in some information. And because I'm lazy, I didn't want to do that. I got a public image. So if I click, it took 45 seconds to provision that container. Here, that's the duration it took. So let's provision that container and see. So I got the FQDN here, the URL for accessing my container. In less than a minute, again, I have containerized or did run my containerized application in ACI.
what is the difference? Like, look like both are doing the same. I mean, I'm not sure how the line things are working.
Between?
By Azure Service Fabric or?
Between app service and ACI. So yes, the difference between ACI, yes, this is for the main difference between ACI and app service. ACI is for running single containers for which scenarios? For example, for dev and test. If you are, the ACI is, the billing is per milliseconds. So if you are running something with high compute power, you will get it charged less than app service. So it depends on for how long you want to run your app. Because for example, in app service, the way you get it charged for app service is per app service plan. So the app service plan is just, you decide how much compute power you want to be dedicated to that machine, and you pay for that. But for ACI, it's super cheap because it's just the number of milliseconds that your application is running.
Can you approach the deployment directly from Visual Studio to Visual Studio Code?
Yes, there are extensions in Visual Studio Code and definitely in Visual Studio that you can push your images directly to Azure.
App service or to the container service?
To both. To both. You can use the Visual Studio tools, or you can use the Docker standards like what I have done here. You can still use the Docker commands. Most of people use the Docker commands because if you are doing that in AWS, if you are doing that in Google, if you are doing that in Azure, you keep using the same commands. And that's what's really great about having one standard technology and all cloud providers are using the same. So the same way you push an image to Amazon, I think they call it Elastic Registry. So ECR, the same way you push an image there, the same way you do it here. But if you want to use Visual Studio, you can as well. I think I have done also some work with Amazon Cloud. You can still use Visual Studio tools to push to Amazon Cloud. Cool. So this is mainly what I wanted to cover on the demo. Yes, sure. In ACI. Very, very good question. Before I answer that, I need to give you a button. Because I missed to say that. So the question was why ACI is not good enough for running production containers. Anyone want to answer? I know the answer.
Yeah, because we have a single container instance and we can only run one instance, whereas if you have multiple nodes and all, it will be very difficult to scale up, fan out.
Scaling. Right. So your answer is correct, but up to extent. So if you're running a single container, that could be a production as well. So you can have a production app, which is just a very simple app. But his question, why it is not good for production? So because of scaling, for example here, in ACI, it doesn't have this smart running on top of it. For example, if the container died for any reason, it's not smart enough to provision itself again. So that's why ACI is not for production. And that's where Microsoft is currently doing heavy investment with AKS, and that's what Ahmed gonna cover more in depth in the next session. He will cover more AKS and ACI. Microsoft is doing huge investment in the Kubernetes project at the moment with the virtual kubelet, and that's where you can run your AKS or Kubernetes cluster on top of ACI containers because it got that orchestrator, which is smart enough to keep provisioning nodes and ACI instances if any one of them fails. So that's why ACI is not for production by itself. But I believe more once these features go GA with AKS and ACI connector together, you can use that definitely for production. Any other questions?
So still going to be ACS or ACI?
You're confused. Sorry, say that again.
So it's still going to be ACI or it's going to be AKS then?
In the other solution, it will be AKS, and it is using ACI in the background. So I have one slide for that to clear any confusion. And that would be the last slide to cover. So here, so we didn't talk about AKS, but quickly what AKS or Kubernetes is. We talked about containers. So AKS is simply an orchestrator to manage multiple containers. So if you have 5 or 10 virtual machines here running multiple apps, multiple containers, enterprise scale application, that's where you need AKS. So this is one of the key messages that I want you all to remember. Use Kubernetes or AKS if your application really needs its power. If your application is simple, run that on app service. If you're running something for dev and test or a single scenario, use ACI. But if you don't have that big, fat, large application that need AKS, don't use AKS. So, sorry, just quickly to answer your question about ACI and AKS together, we have that new feature, ACI connector. So AKS in the background, it have virtual machines that's actually running the container or the pods. So what Microsoft is doing now, instead of running your containers in a virtual machines, and that's the only charges we get, and we all know virtual machines is super expensive in Azure, we're gonna run the pods or the containers in ACI. And that's why ACI was not that good for production. With using that connector, we have the Kubernetes responsible to keep provisioning the pods whenever one fails. So for example, I have an important application and I told Kubernetes to keep running 10 instances of that application in pods. So if 5 pods died, AKS is responsible to provision another 5. If the 10 died, it's responsible to provision another 10.
Another thing that you pointed out, for simple applications, app service is good.
Yes.
So when the service fabric comes in picture?
Yeah, Service Fabric. We didn't cover Service Fabric, but again, Service Fabric is like AKS. It is orchestrator in itself. Service Fabric had its own development models, so you need to be aware that it is mainly written for .NET applications when you develop your applications, but the other ways of running containers, it support everything. So use Service Fabric if you need an orchestrator and still you want that to be dedicated for a .NET application. But most of the people use AKS. Yes?
You have a cheat sheet of
I do. I do have a cheat sheet. That was the last thing. So take a picture of that. If I have a large enterprise app, use AKS. If I have a simple app that I want to run and it is containerized, use app service. If I want to provision one-to-many containers, I want to provision them very quickly and shut them down after that in a short time, use ACI. If your organization can't use Docker Hub, and because it's public and they want to have a private registry, that's where you can use ACR or Azure Container Registry. So, yes?
Fabric and AKS.
Yes.
Maybe we cannot run Windows on AKS, right? Windows.
Correct.
So, but other than that, is there any preference or difference or Microsoft is focusing on right now?
On Service Fabric?
Yeah, versus AKS.
So Service Fabric, most of our, I won't say most, but some of our services internally is running on top of Service Fabric, like Cosmos DB, for example. Service Fabric is meant to be for .NET applications. Yes, it still supports Windows and Linux, but it got its own patterns of writing. You have to be aware of these ways of before you, yes, before you write or develop your application to be deployed in Service Fabric. So the difference between Service Fabric and other, and this is developed by Microsoft. So the difference between Service Fabric and the other service, other than AKS, that it got its orchestrator in itself. So if you need an orchestrator, Service Fabric is still another option. So just a bit conscious of time here. Session takeaways. What I want you to remember, containers are mainly for isolating apps. Never mistaken containers with many VMs. Containers, when they run on virtual machines, they compete for resources. They are competing for the resources on the same virtual machine. But you use containers for isolating apps. You use orchestrator like AKS or Service Fabric, for example, when you want to run your containers at a scale. If you want to have your containers orchestrated, automatically, you use AKS. But if your application doesn't need that power, that it's not large enough to be utilized the AKS power, don't use AKS, use app service or ACI. Microsoft have many offerings or different solutions like what we covered, and it's super important to know where each service fit. There is a bunch of resources out there. I want you to go and see how you can run your containers in ACI. This takes 5 minutes. If you want to provision your AKS cluster, that takes 20 minutes. It's super easy to do that, and all the services would be, AKS is a PaaS offering as well, so it's super easy to do that. So yeah, that was the last thing. Thank you so much. I would highly appreciate your feedback. Thank you. Any other questions? Yes.
I was just wondering with the app services and configurations between dev and test.
Yes.
I know you sort of didn't drill in the configuration section, but like, is there any specific sort of guidance that you could point us toward around
the dev test?
Yeah. So if I've got like a test database, what connection string for?
So if you want to read, if you want to go and read more about this, look for the CI/CD in the app service, because once you go to the continuous integration section in app service, it provisions that automatically for you. So look for CI/CD configuration in app service and look for the deployment slots. This is the main two settings for that.
Great, thank you.
Yes.
There's this new offering like Service Fabric Mesh.
Yes.
Is it to compete with AKS or?
I am not sure. This is not my strength area, honestly. The Service Fabric and Service
Fabric Mesh
yes.
is designed to be the AKS version of Service Fabric.
Okay.
So traditionally with Service Fabric, you cared about the underlying infrastructure and managed the virtual machines and scale and all that kind of stuff. With Service Fabric Mesh, we take on that work for you. So it's akin to AKS Service Fabric.
It's like the Service Fabric manager.
Lots of interest in Service Fabric.
Service Fabric.
If you're doing net new greenfield development, you probably want to strongly link to Kubernetes, unless you have a really compelling reason to leverage Service Fabric. That would be the best advice I would give.
Cool.
Windows container support, sorry. Windows container support is in Kubernetes main branch. I don't think we're yet running that branch available on AKS just yet.
Not yet.
But it's coming. So you'll be able to run Windows containers, and the app service stuff that Omni was talking about, the Windows container support in that is pretty good.
Awesome.
Windows container is not the silver bullet for containerizing your legacy .NET applications. It doesn't solve that problem. Not even Service Fabric. There's no magic silver bullet to take a legacy app and suddenly turn it into a container. You can try.
No, I mean you can pull your applications within Service Fabric.
Absolutely, you can run your executables inside. You can do that in a container if you really want to.
Cool.
Round of applause for Omnia, please. Yeah.
Thank you so much.
I come from a developer background. I'm currently a lead consultant at Redify. I spent most of my life back in Egypt, and I moved to Sydney 4 years ago. I also used to work for Microsoft as a technology solution professional in Microsoft Middle East, doing technical consultancy for Office 365 and sometimes for Azure. Okay, so the main takeaways for this session, it's mainly about scaling, and we're looking at one perspective here. We already been using containers. We think containers are very good for us. We know the workflow. We've been deploying our application in containers. We've been using microservices, and containers is very good for us. All right, and we've been running those and using Kubernetes as container orchestrator. But it gets to a point where we still need to be able to scale. We still need to be able to use more virtual machines. We need to use more resources to run those containers. And the topic today is more about that, how we can scale, but without the burden of having those virtual machines. We need a serverless option. And we will look at the feature that we'll be talking about today, which is virtual nodes. And we will look about this from readiness for production perspective. So that's mainly the points that I'm hoping that we get out of this topic today, just to learn about there is a serverless option, and we can still use container orchestrator. Okay, so with the containers, now we know there is an option that we can run only containers, like with Azure App Services or ACI. But also, we decided that we're moving with Kubernetes, or that's the option that works for us. We need to deploy tens of containers or maybe hundreds of containers. We're having so many containers that we need something to make sure they are up and running, they can be scaled, and they're using those resources, and they are self-healing. And I need to automate the deployment and automate the scale. That's what Kubernetes does for me. But at the end of the day, Kubernetes still runs on virtual machines. I either have worker nodes or one or more master nodes. Those are virtual machines, or you can say still machines if you're running this or on a bare metal. But this is where your containers run. And this is where you will run out of compute and storage resources. So once you start running your application as it gets bigger by time, you will start to need to add more worker nodes. So this is what Kubernetes does for us, and we need to move forward with this. How we can lift that burden out of, and instead of using those virtual machines, how we can use a better option for us. So with Azure AKS, we were able to do this with the master nodes. All the components that runs on the master node, that schedule the containers, that looks after the containers and make sure it's up and running and healthy. AKS is taking care of this for us. So actually, when you provision a service today in Azure as AKS, this is what you get. Azure will be managing this for us, but you still have some virtual machines to worry about. You need to batch them. You need to make sure they are up and running. You need to make sure that you're adding additional virtual machines whenever you need to. You run out of space, you run out of compute power, you will add a virtual machine. So the direction that we're moving here with, all right, we managed to get Kubernetes as a service, and Azure is doing this for us. Other cloud platforms can do this as well, AWS or Google Cloud. But we still, with this part, how we can solve this part, how we can move from virtual machine to a serverless option. All right, so that's Kubernetes. We have seen with ACI also that there is great benefits of using containers. Containers with no orchestrator at all, just containers spread across the space. But you get very good benefits out of ACI. You have very fast provisioning of containers. You pay per second, and you don't have to worry about virtual machines. So this is very good. And if you think it's kind of pricey, it's actually getting cheaper. And just within this month, we had a reduction of price between 35 to 50%. So it looks like this is the direction. ACI will get it cheaper, and it's going to be the best match for running compute power and storage power, or let's say compute power within Kubernetes. So how many of you guys are using Kubernetes at this time? Right, few people. Anyone using it in production, I would say, or at least other team working with using it in production? All right, very good, no worries. All right, so within ACI and Kubernetes, we actually have two amazing worlds in here. I can run containers without virtual machines. I can orchestrate containers and scale them and make sure they are healthy and running well. What if I need to have the beauty of both worlds? Is that possible? And the answer is yes. So virtual node is one of the features that currently in preview in AKS, and it's actually giving you this ability that you can scale and create more containers into ACI, but still manage them using Kubernetes. So how to enable virtual nodes? I'm currently having AKS, and I want to start using this feature. If you're creating a new cluster and you're using Azure Portal as your tool of choice to create that cluster, when you create that, you'll notice that it's actually a new wizard that been updated a couple of weeks ago. There is a tab called Scale, and you'll see a feature called Virtual Node, and all you have to do is just enable that. By enabling this, it will enable a connector that connects with ACI, and that will be your space where you want to spin up more containers into ACI. So if you're creating a new cluster, but if you have already a cluster you've been using, there is an AZ-CLI command that you can utilize, and that will do the same thing for you. So this is currently a preview feature, and it's only available in specific regions, but we're lucky that it's actually available here in Australia East. Okay, so let's look at what exactly virtual node does for us. So we looked at the structure for nodes that we know that AKS, as a managed Kubernetes service, still depends on virtual machines, what we call nodes, to run containers. And we can see the containers are running here in something called pod. So pod can run a container or more. It's actually a group of containers. And this is what AKS is expecting to have an actual virtual machine to be executing those containers. So let's say that we have a request coming to this virtual node that we want to create additional containers. So by default, what would happen, AKS will communicate with this virtual node and will ask to add additional containers in here. This is what Kubernetes does for us. But the thing is, since we have virtual node is actually one of the containers running on this machine, and it says, hey, by the way, I'm actually a node. I'm not a pod. And that's what AKS thinks. He thinks this is actually a node, and it will start communicating with this, and it will ask this node to create containers for us. And this is what will happen. It will actually communicate with ACI, provision containers over there, and it will come back to AKS or to Kubernetes saying, I have created the containers. So AKS or our Kubernetes thinks that there is actually a virtual machine running in here, but in reality, it's not. It's just another container running on one of the virtual machines. And let's see this in action. So within this demo, what I will do is let's look at one of the containers that we have. So I have a cluster here, an AKS cluster that is being provisioned, and it's actually have one node, one virtual machine running on this. We can actually use commands here. So kubectl is basically a command line control that helps us to communicate with, it's too small, let's get that. How does this look? Does it look better? All right. All right, let's try this out. So with this command line, I can communicate with Kubernetes and ask him, how many nodes do you have? So I would say, k get nodes. And I can see here, we have actually 2 nodes. Yep. This is one of the containers that I have the virtual node enabled at. And currently, we have one of actual virtual machines, which is called AKS Agent Pool. And the other virtual node is called a virtual node-ACI Linux. So this is actually a container or a connector to ACI. It's not an actual virtual machine. But Kubernetes thinks it's a virtual machine. So we have seen that there is a command that I can use to enable this feature on AKS. So since this is already enabled in this cluster, I can use another cluster that does not have this feature enabled at. Let me switch to that cluster. And let's get the nodes on this one. And we can see this is only one virtual machine running in here. This one, and the status is ready. So let's execute this command. And let me copy this command from here. I'll just need to change the names. It's running at 2. So the name here gives you an indicator that this is not the first cluster I broke. And while we're doing this, we can actually watch the nodes. So we can say watch kubectl get nodes. And it will take a few seconds. What we're expecting to see here, that there is an additional node that will show up in here. Meanwhile, any questions? All right.
Thank you so much for that. Pricing into version is just free, just services.
So it is the same pricing model that Omnia was talking about. It's still, you still pay per second. It will come back to what scenarios that we expect to do this in. So for example, that you're running e-com website, and in a certain day, you're expecting, or one of the items that got very popular, and you have unexpected load in there, that you actually didn't have enough virtual machines to spread across. And that comes in hand, that it's actually, you will have that burst into ACI, and you're running this compute power, and once this unexpected load goes away, it will turn off all the containers that was being provisioned. One of the other scenarios that you can do this for, if you do have batch jobs that runs maybe every morning or every night or something like that. And so what's happening in here? Still running. What about this guy? So in this case, you don't want to have a virtual machine idle and waiting for those containers to be created. This is a waste of resources. So instead of doing this, instead of having, because usually people over-provision resources to make sure that it actually can take unexpected load. So this comes in handy as well. That comes very helpful. All right, let's see this one. What happens in here? For some reason, it's not there. Okay, let's make sure that we're running on EZ2 and the same in here. All right, so this is basically what I'm expecting to happen in some demos. So that's why I do have 2 clusters. So remember, this is still preview feature, so you're expecting this kind of behaviors to happen. Okay, so let's try to deploy one of the applications that we have here. It's basically a static website that you can deploy to using the same tool, kubectl. You can say kubectl, this is just an alias, and you can say apply using files. And basically, with Kubernetes, it's kind of render the desired state that you want to run your application at. So let's say I want to run my application across 3 nodes or 3 virtual machines, and each node will have 3 containers. So this is a desired state. You write this desired state in a YAML file, and then you pass this to Kubernetes. And Kubernetes will look at the current status and compare. All right, I do have only 1 container running of this application. I need to spin up more containers. So what we can see here, we can get a list of all the pods that we have. So what currently happening, if you remember the image that we had, that there is a request coming to AKS, and it communicates with the virtual node, and it's actually creating those containers in ACI. So Kubernetes thinks those containers are running within my space, but actually they are running on ACI. So if we look here in container instance, we'll find out they are visible in here, but also Kubernetes is aware of that and is managing those. And if you want to take a look at this file, so basically it's a YAML file, defines and sets some attributes, and also select the image that we're using, this image. So it's basically, this is a Docker image that we have within our repository, and we're running this image into containers. Okay, let's switch back to the presentation. Can just delete this for now. And you can delete using the same thing from files, passing these files. And it will start immediately terminating those containers. Any questions so far? Okay.
So the benefit of allowing virtual nodes and allowing nodes in ACI is that you can turn them on and off virtual nodes, virtual while for normal nodes, for normal virtual machines, you will still always have them on.
Exactly. This is definitely one of the benefits that you get. So the question here, the main benefit that we get, that you can turn them on and off. You can still do this with the virtual machines, but we're talking here about bursting into ACI. So let's say that you need 50 containers. And the limit that you have in your node, for example, now you can only run 20 more. You don't have that enough space. But at the same time, you don't want to add additional virtual machine that your operation team will hate running this virtual machine and batching it, and it will cause a lot of problems in future because it's an additional burden that you don't have to. So it's very specific scenarios, I can say. But in the future, looking at what's happening right now, since we moved the managed services, or Kubernetes became a managed service that we don't have to worry about the master node, expect in future that we will have totally serverless Kubernetes. You don't have to, you wouldn't see virtual machines. All you get is Kubernetes API access, and you run containers. You don't have to worry about where is this running. At this time, if you look inside your portal in Azure, you still see the virtual machines. You still have to batch them. If there is any security issue, you have to batch that. You have to make sure you're upgrading the version of Kubernetes running in there as well. So this is where the technology of this area is moving, that everything will be coming as a serverless. You don't have to worry about the the infrastructure running those containers. Yes?
Solve the important issues, like if you're running Kubernetes cluster, right? So Node takes care of the namespace and everything.
Yeah.
When you move these containers to ACI,
Yeah.
where do you manage the, you don't want the container to be exposed outside. Where do you solve those concerns in the setup?
Very good question. So if I can get this right, so you're worrying about controlling the traffic from inside those containers in and out. One of the features they get within ACI, the ability is to work with virtual VNet, virtual private network that you have. Within Azure, you can provision your own network that either connects to your local network or to connect to your data center, and it's closed to your service. It's not accessible from outside. With ACI, this functionality is available. So whenever you provision here, it will actually get an internal IPs. And I'm happy to show you this after the demo. We have one of the subnets that we give to ACI to provision the containers within this subnet. So you'll get a set of IPs that are already within your VNet. Does this answer your question?
Yeah. And then can you communicate between those containers?
Yeah.
Does it go similar, like?
So they're still sharing the same subnet, so they can communicate with each other. They can communicate through, normally through the network or through what you can call, you can have a metadata on those pods and those services, and they can communicate based on that because IP changes. So whenever the container restarts, you might get a different IP. So you're not communicating through IPs, but you can communicate through the metadata that we have seen, the YAML file. You can do this. And also we can have another service on top of those containers. Let's say I have 10 containers running my service, and I want to have load balanced over those 10 containers. This is also possible through containers, and this is coming in the next demo.
What would you do with something like Istio?
Sorry?
With Istio, what would you do? Sidecars, you need in the pods, etc.
I'm sorry, I didn't get that question. Istio. Okay, so Istio is a service mesh that it's very helpful when it runs on top of Kubernetes. It's actually additional containers on top.
So how do you adapt that?
So I haven't tried this connector with Istio, but Istio will help. It will work with this the same way because to Kubernetes, those additional containers are running as any other container. So whatever you do with Istio in terms of controlling traffic, in terms of adding additional security, in terms of having A/B testing or controlling 20% of traffic goes here, 10% goes here, those kind of functionality that you do with Istio, it is still possible.
Istio sidecar is with a pod, right? But you don't have a pod now.
You do have a pod. So with ACI, it's a group of containers. So this is running still as a pod. It's not a single container. That's actually a very good question. It is still a group of containers. So if you have that sidecar, it will be provisioned with that.
It's transparent to the...
Exactly. All right, so what I have seen is a preview feature called Virtual Node, but behind the scene, Virtual Node is depending on a project called Virtual Kubelet. And Virtual Kubelet is open source project started by Microsoft in December 2017. And then it was donated to CNCF. It's open source, donated to, so CNCF is Cloud Native Computing Foundation, and they are kind of the organization that helps with adopting those projects, like Kubernetes, like Istio, and Virtual Kubelet. And other providers can actually support Virtual Kubelet and start building their own connectors. So with Virtual Kubelet, you can have your AKS running on Azure, and the containers are provisioned on AWS Fargate if you want to. So this is what happens behind the scene. Virtual nodes is depending on Virtual Kubelet. So what exactly is a kubelet? Kubelet is mainly the node agent that runs on all the nodes, the worker nodes, and it's responsible for creating the pods or the containers and communicating this back to the master. So if you look at these diagrams, it's mainly, looks like we're doing an X-ray into the master node and worker nodes to see what kind of components are running over there. And Those are the main components that we're expecting to run from Kubernetes. We have here API server that receives the request. We have a YAML file coming, and that gets received here in API server. And then it will ask the controller to compare the state. This is the desired state, and this is the current state. And they find out we need to provision more containers. It gives this task to the scheduler, and the scheduler communicates with the kubelet to start running those pods. So the kubelet communicates with the container runtime, whether it's Docker or something else, and start creating those containers or pods to match the desired state. So this is what the kubelet does. And what the virtual kubelet project is doing is telling AKS, I'm a kubelet, but I'm actually just connecting to a cloud provider that does the serverless containers. So this is, we have seen this before. I'm just bringing this to make sure it's still related. So the virtual kubelet, again, it's visible to you. This is the Kubernetes API. This is the brain of Kubernetes, and it looks at the virtual kubelet and thinks it's node, because whenever this container runs, it registers itself as node, and it says, hey, I can do this. I can create a pod. I can update a pod. I can give you conditions and capacity of this virtual node. So Kubernetes thinks, yeah, this looks like a node that working within the cluster that we currently have. So how is this possible? It's basically, there is an interface that you need to implement. So all you need to do, if you do have another provider that you need to run containers on, let's say you want to run containers on Google Run, Cloud Run. So all you need to do is build an application that implements this interface, and you will have a provider that runs the container for you on this service. So those are the providers that are currently working with virtual kubelet: Alibaba, AWS, Fargate. This is ACI. But this is the current list. But for sure, there might be additional providers working with this as well. I will go through this quickly, but you notice that we do have 2 nodes, and magically, the container decided to go with the virtual node, and there is a reason for this. Because within the YAML file that we wrote, there is actually a specification to tell Kubernetes or the scheduler which nodes that I need to run these containers on. And we do have few options to do this. One of this option is a node selector. It's basically selecting the node by a metadata. Sometimes I have a metadata attached to the node to say what kind of capabilities this node can do. Like it has an SSD, or it has GPU, or something like that. So basically based on that, it's a key value pair that does this for me. I can select the node based on that and specify this is where I need to run my pods. And another thing is called affinity and MD affinity. And basically, with affinity, I can say, I need to run those containers together. So let's say I'm building a microservices, and there is 2 services are communicating with each other very frequently, and I need to run those containers or those 2 pods on the same machine. So with affinity, I can do this. So I can say, if those are related to the same application, run them on the same node. And anti-affinity is exactly what it means is if I need to run a specific pod, but I need to make sure they are not running on the same node for many reasons. Let's say they are very compute power extensive, and I want to make sure they are not running on the same pod. And with taint and tolerations, it's giving me the same thing as well. But with this one, I'm actually applying the taint. I'm applying a stamp to the node. I'm saying this node has a taint, and no pod will be able to run on this node unless the pod definition or the pod spec YAML has a toleration for this. And we'll see this in action in a second. So using a command, I can say kubectl taint the node number 1 or node A, and this is kind of a key value and the action. The key could be anything, the value could be anything. The action says no schedule. If no pod have a toleration for this key, no pod will be running on this node. So the pod definition YAML file must have this toleration. Either it say OS equal Linux and the effect no schedule, or just making sure this key does exist. In this case, when the scheduler looks at this pod spec, it will run this pod on this node. And this brings us to the second demo. Okay. Okay, so with the second demo, we'll just, we will run we will deploy one of the services, and we will look into the YAML file as well for this service. You will find that we do have a node selector here that says which node that we run this container at. This is basically the virtual kubelet, the virtual node that we have. And it has some toleration. So this node already stamped with some taints, and this pod or this deployment have a toleration for this node. So schedule, when it's running, when it looks into the specs, it will actually make sure this pod is running on this virtual machine. So this is very helpful if you have a dedicated nodes that you need to run for a specific application. So let's say I need to run the batch jobs only on ACI. I don't want the batch jobs to run on my virtual machines. I can do this. So I can have a taint, I can have a toleration on those pods, so I am 100% sure that they will not be running on my virtual machines. Okay, so let's do the second deployment. Let's see if there is any specific things that we need to run. Okay. So using the same command, we will apply using those files. And we are watching here the number of pods that gets created. So basically, the deployment is happening right now. The pods are being created. And once it's ready, we will be able to look at this. So this is one of the deployments that actually deploys a load balancer. So we have number of replicas, number of containers running for this service. Let's look at this number. So we have 2 replicas. If I need to add more containers, I can update the replicas here, or can I use a command to scale this deployment, or I can have an autoscaler that looks into the usage of the CPU and memory and then scale based on that. So for the sake of time, let's check the deployment here. So this is basically the deployment that we have in here. And you can see that we have an internal IP address, and we're waiting for external IP address. So even with this, I can specifically tell ACI and Kubernetes that I want to expose this service to the outside, to the internet. And we were just waiting for this IP address to be ready for us. And what it does, it will actually create a public IP address in Azure and attach this to my deployment, to the load balancer. So this IP is actually an IP for load balancer. It's not IP of a specific pod. So if we browse to this IP, here we go. So this is the application that we have running right now. And of course, you can add TLS and you can secure this application, of course. But let's also look at this from the container perspective. So we can see here there are 2 containers running within ACI. And we can also scale this out. Let's see. If you do have another command for doing so. So let's say that we have a load and we need now to scale this instead of 2 to 10. And to make this easier, I will watch. So now there are 2. And this is how quickly that we get those containers created for us.
How does the scale down happen?
So this is not automated scaling up and down. So this is a manual command that I write. You can write the same command, and instead of 10, you can say 1. Yes. So it's another command. There is a horizontal pod auto scale. It's one of the components that you can have within your cluster. You can set a minimum and maximum, and you can define the threshold. You can say whenever the CPU goes over 80%. Exactly. With additional like premises or a few components like this, you can add additional components like number of requests. If you get 50% per minute, add additional container.
What's the max pods for virtual node?
That's a very good question. At this time, they are 800. This is a number that I think it can be changed. But comparing this to the default number that we have on virtual machine, the default number is 30 pod. With ACI, the default number of now is 800. Yeah.
So you configure this thing on the AKS, right? To auto scale.
So no, I haven't configured anything. I just.
What you just said, there's another command.
Yes. Yes. Yeah. Exactly.
And the second question I have is, container instances, they're always running, right?
Yes.
So
they are always running unless you turn them off or unless you have the autopod scaler.
the pricing that you said you pay per second or something. So it's like if container is running, there's always something.
You pay for?
Yeah, right.
Yeah, definitely. Yeah.
So for those workloads, which I need always running.
It might not be the best option.
Yeah, it could be more expensive to run on the
Yes. Yeah. But again, we have seen the price reduction, and moving on, considering this could be the future that we have node-less Kubernetes, we will see definitely more reduction in this pricing. But at this time, very specific workloads could be the best option for this. Yeah. Sorry, I didn't get that question. Okay, so the question is scaling out or scaling up? So scaling up, adding additional computing power. At this time, no. You can easily modify that YAML file in here. From this YAML file, you can ask specifically for resources. I don't have it here in this YAML file, but you can write down how much of CPU that you want, how much of memory that you want, and you can update that as a desired state, and you can rerun this. So this will make sure that you wouldn't have a downtime when you do this upgrade, so Kubernetes will take care of this. It will actually turn off a pod one by one, update it, and turn it back on. Or actually create a new one and turn off one of the existing ones. There is another thing that I wanted to show you is there is something called Kubernetes dashboard, which actually gives you a visualization of the components within Kubernetes. I'm typing here the resource group that I'm using, and the name of the cluster is AKS. Easy. So from here, you can see that we have 2 nodes are running, and this is the pods that we're currently running. It's just one, and you can see that you still see the pods from here, although it's running on ACI. You can see all the deployments. You can look into logs. You can capture some logs from those pods if you want to. And let's reset this. So just making sure that we delete everything after each demo. Okay. Right, so switching back to the presentation. I do have one more demo, but before we do that, I want to bring on Windows containers. Just give me 1 second. All right. Okay, so, right. We have 5 minutes to go through this, so we'll just go through this quickly. The ability that we can run Windows container, let's say that you have the need to run a classic .NET framework application, and you want to run this as part of your microservice, or you want to run this in your Kubernetes or AKS. At this time, there is no way that you can do this. This is coming in Kubernetes 1.14, and the version that supported on AKS right now is 1.13.5 or something like that. So at this time, AKS does not run Windows nodes. And the only way to do this is through virtual kubelet, that we can actually deploy another connector that runs and execute Windows containers for us. I will keep this demo to the end. It's basically we're going to run a Windows container. But we do have a question here. Is this feature ready for production? And it's still a preview feature. And if you enable this feature on a production cluster right now, this cluster will not be supported. So if you want to try this feature, play around with it, just make sure that you're using this on your own development cluster, or you can use this with your own development machine with Minikube. There is few limitation with this feature. Liveness and readiness props are not supported at this time. Basically, those props, as part of the specs that you pass to Kubernetes, and this is kind of the things that the pod reports back to Kubernetes. If I do have an issue as a pod and I'm not running, there's kind of a heartbeat that says, am I still live or not? If it's not live, Kubernetes will restart this pod. And if it's not ready, and we do have this as a part of load balance, it will not get any requests. So let's say one of the pods running into some exceptions or something like that. So this readiness will not be, or you're spinning up a new pod, and it takes some time to initialize that. It will not getting any requests. VNet peering, if you do want to connect to virtual networks. Init containers, sometimes you need to do some preparation before you run your service. Initialized containers are not supported at this time. Host aliases, if you want to modify the host file on your container. And daemon set will not deploy pods to the virtual node. This is one of the objects that run within Kubernetes that makes sure that you run a single pod, not a single pod, but at least you're running this set of pods on every and each node. This is currently not supported, but it's coming on the way. So the things that we have talked about, there is a serverless option to scale Kubernetes. The ACI connector, you can call it. You can call it virtual node. It depends on the Visual Kubelet open source. And also there is a way that we can run Windows container with AKS. Those are the resources that if you want to learn more about this topic. If you're interested, you can also join the community on Kubernetes Slack channel, or Slack. And there is a channel about Virtual Kubelet over there if you want to join the conversation over there. And please share your feedback about this and any questions. Any questions at all? Okay, thank you very much for your time.
So you said there will be support in 114 for running Windows.
Yes.
Possible to mix and match?
Yes. So the possibility in there is you will have a mixed nodes. You will have a Linux node and Windows node. And if you want to run a Windows container, it will be running on the Windows node. So you have a mix that will have within 1.14. All right, thank you very much. Enjoy the rest of your weekend. Thank you.
Thank you guys. Yeah, please don't forget to give feedback and review.
Yes, really, really appreciate it.
And stay in this room because the other guys from the other room join this room and we go for a
Okay, folks, if you want to grab a seat, make sure you give plenty of feedback for the last 2 sessions, please. I'll give you a few moments to submit that. Just going to wrap up the live stream. I'll publish the live stream later. If anyone would like details of it, come see me afterwards. Those watching online, thanks a lot.